Did you get enough sleep? Or did Abraham's story about the Chinese police keep you awake? Or were you simply excited for today? Well, for me, I was simply super excited for today. Abraham's cloudpad stories on the Chinese police definitely didn't give me nightmares. Definitely, totally not. Our first presenter for today is the lab director of Shepherd Lab of JD Security. His research topics are mainly on embedded device, hardware security, blockchain security, and reverse engineering. He presented his findings at DEF CON, HITB, CodeGate, QCon, KCon, RuCon, H2HC, and many more. Besides conducting hacking courses, he's also the owner of hackersbatch.com and is actively involved in unicorn development. KaiJern, with his presentation on Qiling framework, instrumenting the uninstrumentable. Let's welcome him to the stage. I mean virtual stage.
All good? Can anybody hear me? Hello? I'm like properly live now.
Yes, you're properly live.
Okay. All right. And first of all, I'm not too sure why these fellows, friendly Malaysians, wanted to mention about Chinese police right before I start. But anyway. So this is me, all right. I work in this company called JD.com. By looking at the name, most probably you can guess it's a Chinese-based company. And yes, I stuck in China since end of January until now. This is the longest moment in my entire life that I missed nasi lemak for 10, 11 months, and it's going to be bad. And I'm not too sure when can I go back for curry mee, laksa, nasi lemak, and whatever food that, rendang. I miss rendang too. But yeah, I'm in China right now. I'm a Malaysian, and they want me to specifically mention I'm from Penang, so that's pretty much me. Most of the time, during my office hour, during my non-office hour, I'm doing a Qiling framework. In all the presentations and all the different people that we meet during this entire development and sharing this project, just like how we shared, just like how people shared all the good things in their life, there is some feedback and comment, especially from Chinese. They say Qiling's proper spelling is Qiling and Qilin, and why I spell it Qiling. The reason why I screwed up when I did my spelling. So that's pretty much it. Some of them pronounce as Qiling, whatever. It doesn't matter as long as this is a framework. I also did some batch, for Hack in the Box and cover conferences, all right? And the rest is not important because you're gonna see that later in the slides. Okay, so I will take this as an example. Okay, I will take this as an example. The reason why it's and this example is a little bit over exaggerated. Just imagine any IoT hackers. Okay, of course, Qiling it's not limited to IoT, but just imagine any IoT hackers or firmware hackers or any reverse engineers. They wanted to reverse a car. So the rule of thumb for IoT hacking, it's you need to have the device before you can reverse the firmware. But the entire idea over here, it's just imagine if you need to reverse a car, you need to have the proper car, and then there are how many models of car you want to have and how many brand of cars you want to have. All right. In Malaysia, maybe we can do it, we have a big garage that most probably you can put 2 or 3 cars, and that's only 2 or 3 cars. Okay, and you are expecting yourself, you don't want to break the car and during the entire reverse engineering process. So the entire idea of Qiling framework, it's without owning the car. Again and again, I say that this is just an example. So without owning the car, can you actually reverse all these IoT devices? Okay, so let's say to fake the GPS, to fake the Wi-Fi, to fake the Bluetooth, to fake the audio devices, you know, to emulate the screens along the way when you do your entire reverse engineering. So the entire design and idea over here, it's you wanted to have a framework that can help you to emulate all the connections. Okay, again, Wi-Fi, Bluetooth, or whatsoever, and you will be able to have the complete emulation for your to have the complete emulations for your reverse engineering purposes. Okay, so that's the entire idea when we started to design a Qiling framework. Oh, can I say hi to Ken Seong? So when we reach this stage, okay, the only thing that that people ask is there are virtual machines, okay, at least at the very bare minimum, at the very minimum stage, you do have a QEMU, but QEMU will not be able to bring you to a lot of places. Okay, so let's say you need to emulate MBR. Yes, Bosch will be able to help you to emulate quite a fair bit of MBR, but how are you able to do instrumentation on MBR? You cannot do it. You don't have the proper tools and the proper you don't have any proper things to do your instrumentation on your MBR smart contract. There is quite a fair bit of emulator out there. You know, people can emulate, people can, but when it comes to instrumentation, when it comes to fuzzing, how can you fuzz a smart contract? You need to build a bit part and parcel of everywhere of tools, and you know, to match to make some other non smart contract design to tools to in order to make this thing works. Okay, UEFI, I don't think there's any proper UEFI emulator out there, all right, except us able to emulate UEFI. Let's look at things like Qualcomm EDL, a very low level system inside a Qualcomm chips that able to help you to unbrick your phone, that it's not patchable, and apparently there's quite a fair bit of bug. So in order to emulate and to instrument and to run these things, okay, there is no proper emulator for you to do it. Okay, so virtual machine will not be able to help you to emulate or to instrument all these kind of tools. Of course, when it comes to any OS debug, so let's say your kernel drivers, your binary, you want to do there is a debugger detected, or there's anti-debug techniques. You know, how are you going to solve it? I mean, you can solve it easily, but what if you do have a system don't have any anti-debug mechanism? That will help you to solve a lot of shit. Okay, the one of the last thing that I mentioned, it's more from the previous slides. It's hardware emulation. So let's say you want to emulate some GPIO connections with some proper hardware to fit into your IoT system. So that is most probably the most important thing for IoT reverse engineer, and to emulate all that kind of hardware. That is what we can do. So this is the entire overview of Qiling framework. Okay, and this is what you're gonna what you're gonna have. The very base design of the framework. It's the framework itself. Of course, it comes with CPU emulations, loader, OS, debugger, all the way to extension, and then in the middle And somewhere in between the external hardware emulation and instrumentation, you do have all kind of, you will be emulate all kind of hardware. Okay, depends on how you want the system to do it. Okay, how you want the framework to run it, and what kind of data you want to fit into the framework. And then you do have the CPU architecture. All right, that is what we support so far. And then when it comes to the loader and OS, it's two different things, but for a lot of people, it's going to be the same category anyway. So you have your Linux loader, your BSD, Mac OS, Windows, DOS, UEFI, Qualcomm EDL, master boot record. We are still finding ways to run iOS, and then we can run quite a fair bit of Mac OS binary, but still not really there yet. Okay, and on the debugger part, okay, the debugger part, we do integrate IDA Pro, be able to run with IDA Pro, and then we do have our small little QDB toys that developed by one of our contributor that will allow you to do reverse debugging. So you can step forward, you can step backward, and then all sorts of stuff. Okay, so and then we are still planning on G-Hydra, and of course we support GNU debugger. And the extension part, we really have a few things running. We have a heap sanitizer, we have our coverage, guided coverage, and we do have a report generator that able to generate all the JSON files, the information that required by the malware analysis gang. So these are pretty much the overview of Qiling framework. Okay, so the features and functionality is pretty much here, like or what I mentioned just now. The only thing that I would like to add, it's we support cross-platform and cross-architecture, not only on the emulation part, but simply on the also on the execution part. So you can run a Qiling framework on Windows, you can run it on Linux, you can run it on Mac, and you can also emulate these three systems. All right, and also on different architecture. All the executions, it's on sandbox, and it's in an isolated environment, so you don't have to worry about they are messing with your actual file and system during the entire emulation, especially when you are emulating malware, APT, and so on. Okay, so of course the most important thing over here is the instrumentation. So what kind of instrumentation we able to provide into all these CPU architectures and OS? Of course, you can debug. We can even debug step forward up to the stage of UEFI or MBR or Qualcomm EDL or up until that level. Okay, and then we do have this small little thing called OS profiling support. The entire idea of OS profiling support is you can do your settings. You can set up your OS before you run the entire system. So just imagine you wanted to run a firmware that's suspect from Russia, all right? And then you want to emulate the entire system that looks like a Russian system, a Russian keyboard, a Russian Windows. You can do it. And then you can have another copy of emulation that runs on let's say on the Chinese system. So you can set your Chinese language, your Chinese keyboard, or whatever. So it's everything on one configuration file that you can do all kind of OS profiling based on the reverse engineering conditions that you want to go into. So this is the entire design that allowed you to change the settings and just put and just runs your system. So and then recently we see quite a bit, all right, not to say a lot, but there are 2 or 3 similar projects that pops up either at the same time that we release or slightly earlier. We release a Qiling framework or or until the current stage. All right. So of course, when it comes to reverse engineering for IoT devices, especially a cross-platform Linux-based system, the most common tools that the reverse engineer previously used is QEMU user mode. Okay. Few problems with this and a few issues with this. Number one is all these tools are all QEMU user mode are designed as a tools. It's not anything for reverse engineer. It's able to emulate, to run, and they are not able to do anything else. Okay, and one of the dead end for reverse engineer, it's rely on syscall forwarding. So if you need to analyze a Mac OS example, Mac OS file, you want to if you want to emulate a ELF binary, you will not be able to do it on a Mac or FreeBSD or even Windows. All right, you need to be in the same host to emulate the same the same target that you're gonna look at. All right, and then a couple of years back, one of the guys they released a thing called UserCon. All right, good and bad things. Okay, it's a framework. It's able to do some level of instrumentation. But the only thing is they rely on Go and Lua language. It's not a hacker-friendly language. Okay, I know a lot of people are gonna bash me for this, but I'm still gonna say it. It's not really a hackers-friendly language. Okay, and we do have things like Wine. Okay, we do have things like Wine. They're able to run. The only limitations over here, it's not only limitations. The limitation, it's they doesn't support multi-arch. They doesn't have a lot of OS support. All right. It's not a sandbox design. They only support Windows. It's not sandbox design, and then you don't have instrumentation. All right. So the new player on this ground, okay, after we release is number one, of course, is Beanie from Carbon Black. They only support Windows, and they only support 32-bit and 64-bit. Again, it's running on Golang. They release around last year's if I'm not mistaken, last year's DevCon, but it's not really active recently. At least for the past 6 months, they are not active at all. And then Zelos and FireEye. Zelos is from one of the company from the States. Okay, of course, FireEye is from that part of the world too. Both of them are framework. Okay, Zelos only supports Windows. Zelos only supports Linux. SpeaksEasy only supports Windows. And SpeaksEasy, yes, they can do PE files and Windows driver. All right, Zelos. They only can do ELF file, but not Linux drivers. So not Linux kernel module. So you do have all these projects running around, but they are not complete in the sense of they are not cover a lot of platform. They are not cover a lot of architecture. They cannot cover things like from files to kernel level, which we can do it. And then they don't have a very complete, a lot of them don't have a complete instrumentation, which we are our strong forte. So when it comes to explaining Qiling, you know, I'm working in this part of the world, and then sometimes I do have to explain what is Qiling and framework, and a lot of people don't get the idea of a framework. So when we started to share our session, a lot of people will started to ask, you know, what can your tools do? It's not about what can our tools achieve or what can our tools do. It's all about what can you do with what kind of tools you can come out with our framework. So there is a couple of projects started to use Qiling. One of them is from tools from Sentinel-1. You know, we have things from this FireEye inside our plugins, and then we have this very good reverse engineer that does the VAC emulator. So they started to build UEFI fuzzer, malware decoder. You can even build a malware sandbox, and then you have things like iOS emulator, macOS emulator. These are the ideas that you can build on top of our Qiling framework. Of course, not limited to all these kind of all these tools that I mentioned. All right, you can build more and more stuff using a Qiling framework. And why I split into the CPU architectures, loader, OS, debugger, and all these things, because we do have instrumentations connections, or we call it the Qiling's API that you can connect to, and then you can start to do all the things within the framework itself. So the topic of today, we're going to talk about instrumentation. So when it comes to instrumentation, all right, when it comes to instrumentation or the API that able to help you to instrument your reverse engineering activity, the thing over here, it's you have, so example, you have a binary, and then the binary will execute from A to B, and then to C to D to E to F. All right, so 1, 2, 3, 4, 5, 6 steps, and then that's the end of the binary. Okay, so instrumentation simply means you wanted to start at B. Okay, and then you're gonna change the you're gonna update the syscall, or you're gonna mess around with the syscall, and then you're gonna mess around with the functions call, and then you want to skip C, you want to continue D, and then you're gonna change the CPU register, then you're gonna end in E. Okay, that's the entire idea of our version of instrumentation. So reverse engineers always knows that you want to skip certain part of the binary during analysis. The entire reason it's there might be some part that you don't need to analyze, and that part is a big chunk of code that might take up a lot of your time. So if you can able to run it this way, then that will bring you to another result whereby you can actually run this thing. You can actually run this binary over and over again in a fuzzing process, like what Ye and Nafis shared yesterday. So you can run over and over again in the entire fuzzing process for you to fuzz only this part of the file. So instead of wasting 10 seconds, all right, for you to run through from A, B, C, D, E, F, and now you might be able to run B, C, B, D, and E with all your syscall authoring, your function authoring, your CPU registration authoring. Okay, then you might finish in 2 seconds. So this is how you can able to save time for during your entire fuzzing and discover more bugs efficiently without running or analyzing the code that you don't need to. So that is everything about instrumentation. So this is the API. So what do we have inside our Qiling's API? It's we split into the CPU level, operating system level, file system level, virtual machine level, and the debugger level. So after we load in the file, it's either ELF file, the MBR file, or the DOS.com file. Then that is where all these things started to kick in, and then that is where you can do your instrumentation. So there are some API that perform the instrumentation is a little bit cross-border. So it's either in file system or it's either in operating system, or they're in both places. But please bear with me. There are certain parts the API is the definition of the categorization of the API is a little bit blurry. So they might be here and there. So please don't mind. So for CPU register, CPU register alteration is very simple. You can either change, or you can either read the register. You can write into the register by using the API. So this is the example. You look at the highlighted part, that will be your RAX. Okay, so that will be your RAX, and then this is how you can read your RAX. This is how we can you can update or replace the RAX. So this is what you have. Down there will be a little bit more API that we will be able to share later. So that will be like, you know, replacing syscall during enter into the syscall, updating syscall when you exit the syscall, so you can do all that. And then there is a thing called set API, that is your library replace function. So you want to replace a certain function inside your libc. Yes, it's totally doable. So you can read map, you can map, you can do all sorts of things. Okay. So in the operating system level, there are certain things that you might be interested for a lot of people. You can read the memory, you can write into memory, you can even do a pattern search inside the memory. So when you are emulating a ELF file, you want to search for certain strings. So let's say a simple CTF solver. So once you are running it, and then you just want to search for certain strings that starts with what kind of character and end with what character. Yes, it's all doable over here. So for your pop push, for your stack related operations, okay. Like what I mentioned just now, syscall or library replacement, everything can be done from here, regardless of you're emulating a Windows or Linux. So that's an example over here. So this is a very good example on how you can replace a Windows syscall. You can replace a Linux syscall right into your own implementation of syscall right. So we also have file systems API. File system level API will be things like so let's say your STDIO replacement. So you can hijack STDIN, STD out, STD error. Okay. We even have things like patch. So you can patch the file during executions, and then you can test out the executions if you want it. Okay, along the way, then only you decide where to patch the file physically. Okay, so the patching inside a Qiling framework is you look for address, and then you replace the execution code before you run it. So this is how you can patch the you can actually patch the entire binary without touching the actual file. So we also have this thing called a file system mapper. So you can always map a file. You can always map a file into your host system. So if you want to during the entire emulation, you want, and then you discover your binary is actually taking urandom, you can always map your file into the host system's urandom. That is where you can get your proper randomized value. So if you are not interested in doing this thing, you know that your binary is running on is doing a urandom, and then you do expect, okay, for some reason you only want your urandom to return hex 01 value, and then you know that regardless of what kind of for whatever reason, you only want your urandom to return hex value 01, then you can always force your urandom to reply fixed value reading for your urandom to return back that kind of value. So you can do that. You can force that kind of a value. The virtual machine, it's very simple. So the virtual machine state is just imagine you're running on a VMware and you want to do a safe state. So during the emulation of that binary, you can choose to save the entire snapshot. So that includes the CPU register, the memory layout, the FD. So you can save the memory regions, you can save the register region, you can restore the register region. So that will be able to allow you to do your fuzzing. So we do have a small example over here. So you can save, then you can restore back, and then you can start from certain parts that you want. So we don't have the start of certain parts that from the binary. So just imagine you can always save, you can always analyze a part of the file, and then you know that you want to start from certain address, and then from certain address the next execution, the next execution, or whichever execution, you always wanted to start on that part, and you want to patch a certain memory or certain area of the binary, you always can use these functions to do it. That will save a lot of code executions when it comes to things like, you know, how you want to mess around with the entire systems, and your binary, where to start, where to stop, and how are you going to how are you going to able to patch it. Okay, the last part will be the debugger. So the debugger part, it's rather simple. Whoops. The debugger part will be rather simple. So you can switch to a different debugger. You can switch to a GDB. You can switch to our own small little QDB that are developed by the community. So that's pretty much about the debugger. So you have your file pass into the framework, and then the framework will load and set up according to the API, the instrumentation that you put in. Okay, then you will be able to run to emulate the file, and then you have your engine, and then the rest will be the results on how you can analyze the system based on the result and the output. So I think this slide will be distributed by NanoSec, so you don't have to copy or screenshot these things. Okay, so these are the certain things that you can do. Okay, you can analyze malware without having a full execution of Windows. You can just analyze by using a Qiling framework. And then yes, we support PE file, and we support a .sys a contribution from demigod teams. Okay, then we have all these anti-debug system. Basically, we don't have any anti-debug system, so any anti-debug code that comes into Qiling framework, they will not work. So it's a good thing for everyone. Okay, and then we have this cross-platform support. Of course, you can run in Windows. You can run your Windows code in Linux or whatever. You also can build a fuzzer that is inside our example. So inside our GitHub repo, then there is an example. So you can put in your code. You can start to test out the different fuzzer. I will show you a video on MBR analysis later. So this is from one of our team member. He wrote the MBR analysis, and then he recorded the video, so you guys can take a look later. IDA plugin also from the other member from our team. So the entire design over here, it's we wanted to use IDA, the strong IDA function that you can do reverse engineering, you can do all kind of stuff, and then we wanted IDA to have the instrumentation features in IDA Pro. So in order to make this work, we need to write an IDA plugin, and then to make use of IDA reverse engineering features, okay, to bridge over to a Qiling framework, and then that is where IDA will have their instrumentations, the power of instrumentation. Inside IDA, we also can make use of the IDA to do the execution path drawing. So in execution of one binary file, you will know that which part of the which part of the file is actually being executed and which part it's not. So we will be able to draw out the entire execution path. So it's much more easier for you to trace when it comes to reverse engineering. So I'm going to show you some demo over here. So okay. So this is the code for to analyze this thing called Dodgy 8086. So it's basically a flare-on 5 challenge for MBR. So what we did is we load the entire MBR into Qiling. Okay, and then it goes into a first stage, second stage, and third stage. Inside first to run it, and then we're gonna hook in a certain part where to start and where to stop. And then this is how it looks like during executions. So there is a specific requirement for the date. So you need to make sure your system date is February something 1990. So what we're going to do here is we're going to change the required time. So from here you can see we can set the API, the required date into a specific date that we set. So you don't have to change your BIOS time or whatever in order to run this kind of analysis. We are the system, so we can control the date time. So once we change the date time, then we will be able to execute. So you can see the second stage is the one that we started to do some sort of key guessing. Okay, we do have enough time. So we're going to calculate and search for the possible keys. Okay, and then the third stage will be to print out the keys and then to test out the keys. So it's 3 different stages. One is to do the times, to change the timing. The second part is to generate the keys. The third part is to test the keys. Okay, so this will be the entire demo all about, and this is how the code looks like. So you can see we use a different Qiling's API over here. We use a ql.restore to store the stage memory, right? To change the memory segment, okay, and then to run from certain part and end in certain part. All right. So that is where the code from 801B and then to 803D that we highlighted just now. So to restore the code, to run the code on certain steps, and this is how we execute the code. Then this part, we will actually change the time, okay, and then we discover the possible key, bunch of possible key. And then after we decide, after we able to search for the bunch of possible keys, and then we will test one by one until we get the right key. Okay, so this is one of the right key, another right key, another right key. So this is a very classic nice CTF. The reason why I said so is you have a few possible keys, so you might have a few possible answer for your entire solutions, but they only display one email address. So that is the email. So for whoever familiar with flare-on challenges, you will know that you need to come up with you need to send an email, the specific email address that will be the answer for your entire CTF solutions. Okay, that is flare-on, one of the level for flare-on 5, and okay, what do I have? So this is another binary also on flare-on 5. Or didn't mess up the flare-on series on these things. So this is how we can use IDA together with Qiling framework. So we can load our plugin into IDA. Okay, so this is still we did the recording sessions earlier on, so we're still on 1.2 dev. Okay, so so you can see there's a lot of a lot of code that you need to analyze inside the entire system, and then that's where they of course that's where they validate and to check the input. So these are part of the code that pretty much you're unsure on how and what will happen to these things, and then you can see it refers to a magic table for the encryption, and then you have your encryption and decryption function over here, and there's certain parts that you cannot easily analyze. All right, so we load in that's where we can load in our tools, load in our framework into a Qiling framework. We can load in a Qiling framework into IDA Pro. then that is where you can start to analyze junk code like this, all right, in a proper way. So we're going to check the functions over here, which again another bunch of things that you don't want to see. Then there's some breakpoint being set. So like what you can see from this binary, a very typical CTF challenge, a lot of code which is being messed up, and then these are some of the things that if I'm not mistaken, we rename during the recording process. So once looking at the code, and then we need to load in our custom scripts, okay, and then the binary file and the root fs. So during the execution, it will execute two things, okay. Of course, the binary file together with the scripts that we wrote just now. So that is where you can view the register. Then you can view the memory. You can view the stack. You can view the you can have the complete memory view. So you can see the stack once they stop there. So the RCX value is identical. So then we need to check out the where's the RCX value. So that's the RCX value inside the text segment. So the code is going to be messy for now. Then we can have the more readable code over here. Then you can even F5 it to look at it properly. Then you can start to do your code execution. Continue running it. So this is the custom script that we're going to show it to you later. And I think it's in our repos example, so you can take a look at our repos. So you can simply restart the engine. You can restart the scripts. So this is the path executions drawing. When does it start? Where does it stop? And then how does it run? So the green color, the one in green is it's all the code that are being executed. So instead of junk F5 code that you have seen just now, so this is the translation of the code that into a more readable manner for reverse engineer. So everything is from the combination of the strong reverse engineering binary reversing power of IDA, and then to combine with the instrumentation for you to get this kind of result. So that is the demo. The only thing over here, it's where is my, so the only thing over here, it's there are quite a fair bit of things that we need to complete. Number one, it's can we need to work on Unicorn version 2, the entire backend of our CPU emulation. So the relationship is Unicorn will be handling the CPU emulation. We will be handling the OS level emulation. So can we have the latest CPU? That is what we wanted to achieve in these few months. Hopefully this year or not early next year. Okay. Android Java bytecode instrumentation. That's something that we are looking at right now. Of course, to emulate iOS, not only iOS, okay, but also Mac OS ARM64 version. Our Windows API is farly not enough right now, so we need to have more Windows Cisco or Windows API. So we are still looking at Wine or some other options to make our Windows greater. All right. MCU emulation, yes, that's part of it. And then smart contract emulation, we already have we are making a very good progress on smart contract emulations, and hopefully we will be able to release that in a couple of weeks time. Okay. Join us and please make a pull request. We don't have any we don't see any code contributors from Malaysia yet, so if you guys are interested, please contribute to the project. So all the informations on the it's right over here, the website, the GitHub repo, documentations, our Telegram channel, okay, Twitter, and please go to our repo and give us a star, or else we're gonna be very sad, every time we give talk and then there's no star. All right, and questions? I think you guys will be able to ask from YouTube, no? Oh yeah, we do have no. Somebody told me about Marcus. Yes, Marcus is he's not a contributor, come on. He's a core dev, so it doesn't he doesn't count. It's not the text is from my Telegram, not from YouTube. So any more questions? Bloody Queen. Can you update your QEMU and stop messaging me? You shit. I will ask Chinese government to send an army to Singapore to catch you.
So there's one question. What is the optimal requirements to run Qiling?
What optimal? Are you talking about CPU requirement or RAM requirement?
I guess so.
Well, you can run it on Raspberry Pi if you want. And you can use Raspberry Pi to install Linux and emulate Windows using Qiling. Perfect.
There are questions in the Zoom chat, if you can check. This is an off-topic question. They said, no freebies like stickers or t-shirts this round. I think this is a note to last year's presentation by you.
Well, I mean, how the fuck I can give it to you guys? That is the questions. I can give, it's like what? Like that? or like that. Hey, take a snapshot. That's yours. Who asked that question? I gotta cook that fella, man. How am I supposed to look at the chat? Where is the chat? Oh, all right, there you are. Okay. There's somebody asking, is this session being recorded? No, yes, I don't know. Well, I think YouTube will have some replay for sure. Any more questions?
No, there's no more questions.
Okay. So anybody from Malaysia care to send me some nasi lemak? Okay, then we are good. Thank you very much.
Sniff it, Wilson.
Sniff it was a nasi lemak. Okay, sniff it, sniff it. I'm gonna wait for you, man. Sniff it. Like DHL. 2 hari lambat.
Post lagi lambat.
I can show you Malaysian or not. Oi. Don't like that lah.
Okay, thank you, KaiJern, for your presentation. So the next talk will be, I can fuzz my junks for less than $50. Okay, so Turla is a manager in security operations at Bugcrowd in the Philippines. He's been recognized and awarded by giant companies like Facebook, Adobe, Microsoft, and Mozilla for his disclosures. He has presented at RootCon, HitCon, PechCon, DEFCON's Packet Hacking Village, DragonCon, besides Myanmar, NALCon, and PCon. Okay, I'm sorry. We'll see you at 11.
All right, can you guys hear me?
Yes.
All right, so let me just try to share my screen now. Oh wait, it says 1 sec. Oh, okay. All right, no problem.
The next talk will be I Can Fuzz My Junks for Less Than $50 by Jay Turla. Jay Turla is a manager in security operations at Bugcrowd in the Philippines. He's been recognized and rewarded by giant companies like Facebook, Adobe, Microsoft, and Mozilla for his disclosures. He has presented at RootCon, HitCon, PayCon, DEFCON's Packet Hacking Village, DragonCon, Besides Myanmar, NALCon, and TCon. He used to work for HP Fortify in vulnerability assessment, remediation, and advanced testing. His main interest right now is about car hacking and is currently one of the main organizers of the Car Hacking Village of RootCon, Philippines. Please welcome Jay Turla.
Hey, good morning to each and every one of you, and also good evening to people on the other side of the world. Uh, yep, so let me share my screen about my slide. Okay. All right, let me just present it. All right, so um, I'll start now. The title of my talk is I Can Fuzz My Junks for Less Than $50. And my name is Jay Turla. You can also follow me at Twitter at shipcode. And then pretty much like I've been introduced already in the by one of the NanoSec Conference crew. So yep, this is my short bio. And just to add, I'm also one of the RootCon Goon or CFP review board, and also I contribute to Metasploit modules and auxiliary modules as well. And I'm also a member of Ad Vulcan, which is a CTF team. We were finalists during Hackasat. We were able to place finals in the aerospace village. So it was really fun, and I can't believe that we actually made it that far. But it's really good. Anyways, let's start on my talk. So just to give you a short overview on why we like Car Hacking Village is because we get to share our knowledge about how to fuzz some of your test bench and also anomaly detection systems. This was taken last year actually, and sad to say we were supposed to bring some car in our conference, but didn't work out because of COVID. But I hope that maybe next year we could present our actual car and show show some of our hacks and also our ECU tuning hacks that we have. So this is also one of our ECU kits that we have. Uh, there's a BMW ECU kit and we have a Mazda 6 ECU kit. Uh, you may want to maybe have some doubts, or maybe you're saying that, oh my god, this guy is spending like a lot of dollars on his arsenal or hardware. No, if you actually total this two together, it didn't cost $500 just for these two ECU kits. So I actually bought this one for just like, if you total them together, it's just gonna cost like $250, 250 or the $300 plus the shipment, of course. And I'll try to share my, knowledge on how to acquire these parts for cheap. Okay. But this is not our main topic. I'm gonna show you how to, start, you know, with less than $50. How are you going to start with car hacking? Okay, that's the main point. So before all else, this is the best car hacking book ever. And in fact, I've just received an email that the Car Hacker's Handbook will be, uh, Craig Smith is actually working on the second version of this book. And if you want to buy the paperback, it's going to cost $35. But if you just want the online version, it's for free. The link is provided in the slide. And Craig Smith is actually one of my idol or mentors because um, the book is really one of the reasons why I started car hacking. To tell you guys the truth, I started car hacking not through canvas hacking. I started with um, infotainment hacking, and in fact, I've actually, if you want to review my previous work on infotainment hacking, so, so you can see my there. So if you just refer to this link for DEF CON, I presented it like DEF CON 26. So yeah, just refer to that one. I've actually shown some of my methodologies on how you can hack an infotainment system. All right, let's go back to my talk. In this talk, we'll be focusing on creating your own sniffer and also creating, playing with your own cheap hardware. Okay. So, is there money in car hacking? As a bug crowd employee, I've actually helped in triaging bugs for two car hacking bug bashes that we have. The second one was in Detroit. It was last year, and I really had fun because I played with some of the hardware that the company of the automotive company that hosted the bug bash provided, and we actually were rewarded 224,000 US dollars uh, to hackers that have provided their proof of concepts on how to hack the cars or how to play with the hardware or how to bypass the firewall of the cars. Right now, it's not that easy to just hack cars right away. And in fact, right now, since 2018, there's a firewall called Security Gateway for cars. And from what you can see on the list, okay, the top 10 hacker is Leonard Hu. And so what you can see, he actually have 43 points. And there's actually a news today wherein he provided his proof of concept or video on how he was able to hack a Tesla car, the key fob of the car. Okay, you might want to search Google and just Cossack B. The keywords are Cossack B, Leonard, and then uh, Tesla hacking. Okay, that it's just a new article, and there's a video that was provided on how he did that, or his proof of concept. Okay, these are sample attacks carried out on the attack surfaces. When you say attack surfaces, these are the entry points for car hacking or into hacking the car. Take for example, we have CAN injection attacks on the controller area network or the CAN. We have the OBD2, which is the onboard diagnostics. We have the sensors. You have the unprotected components, and then you have the radio attacks. Right now, we have key fobs. We have immobilizers for a car, and then we have key fob replay attacks and roll gem attacks. Right now, most key fob attacks doesn't actually work because of immobilizer and rolling codes. So what you're going to do is you need to perform a role jam attack, and Sami Kamkar, who is our hero, for sure, he is also your hero. Sami Kamkar has presented a good topic on how to perform role jam attack on key fobs. Okay, and then another thing is because your car has a lot of hardware, it composed of a lot of computer boxes or ECUs, like there's 100+ hardware or ECUs in your car. So for car hackers, it's actually their free real estate in a bug bash, because they can do hardware attacks, they can do side channel attacks, they could connect to the debugging ports like UART, JTAG, SPI, or everything. The bootloader, hacking the bootloader. So it's actually one of the sample attacks that they carry out. And then we have IoT hacking on infotainment systems, FMS, or the fleet management system. And then we have the telematics. When you say telematics, it allows the car to be connected. It's a module that allows your car to be connected. And then we also have web and mobile attacks on certain endpoints, because some infotainment or some cars have web service and web servers running. Or for example, if you want to update your radio head unit or your infotainment system, it connects to a web service for the download, right? And if you actually find an SQL injection attack, or if you could modify the firmware, that's actually an issue right now. Okay, and if in a bug bash you could actually demonstrate that, it's actually a good issue. Like you could be rewarded for like 10,000 USD to 25,000 USD. Now, don't get me wrong. P1 issues that we have, for example, if you could actually bypass the firewall of a car, it's usually 25,000 USD. Like take for example, sending an ECU reset message on the car, even though there's an SGW on it, and then you're actually able to do that on the dirty side, not on the clean side. That's a bypass or a security issue. So it's pretty much like 25,000 USD. Okay, that's the minimum. And then next up, we have the DOS or denial of service attacks and memory corruption on these services, which are still part of infotainment systems and radio head unit. So you have the Bluetooth, you have the Wi-Fi, you have the services, of course. Keen Labs has actually a lot of good white papers. If you try to search on Keen Labs hacking on BMW, they actually have a good white paper and proof of concept as well in the net. This is a sample of an unauthorized CAN access. Reference is from the Black Hat demo of CAN tools. And as what you can see, if you're actually going to rip off some of the parts of the car, you can actually connect to the controller area network. So you don't need to be in the controller area network internally, or you don't need to be inside the car. In fact, if you're gonna rip off maybe the adaptive cruise control or the chassis bus or the brake lights, and if you use a multi-tester, and if you're gonna measure the voltage of two wires, like it's usually twisted, like it's red and green, and if you're gonna measure like 1.5 volts, that's usually where CAN is actually traveling. So just so you guys know, airplanes and motorcycles have CAN too. And the reason for this is to reduce the number of interconnecting wires from control panels in the flight deck to system computers in the avionics compartment. So that's why there's an Airbus deployed CAN bus. Thus, CAN is also present in airplanes. So most of the dilemma right now is car hacking research is expensive and costly. It actually isn't. Okay, so let's try to bust the myth. Uh, First of all, without spending dollars, if you don't have any hardware, you only have a Linux box, You don't need to have a problem with that. Okay, you can just run Instrument Cluster Simulator or ICSim by Craig Smith, the author of the Car Hackers Handbook, and there's a lot of tutorials in the internet about this one. And for you, if you don't want to try that one, you could also set up your own virtual CAN device without an actual device. So this is a bash script that I provided, and because I'll be sending my slide, I don't want to, focus on this one, but this actually allows you to set up your virtual CAN device without a device. And when you say virtual CAN device, it's similar to this. Okay, let me just show you. All right. Let me just share my screen, my whole screen, so that I can actually, let me show my whole desktop so that I can show my virtual machine. All right, now let's go on to my virtual machine and just show you some part of this one. So, right, and then if we try to, I've already cloned the IC simulator, and there's actually a script called setup vcan. So if you try to run that one, it would enable your virtual CAN. So as what you can see there, we have a virtual CAN device, which is vcan 0, and we can start dumping virtual CAN network. And if we try to send a message, take for example 123, that's the arbitration ID, and then 1212. Sorry, we need to define the virtual interface. And then we'll have there, okay? We have the message that was sent. So this is the virtual device, this is the arbitration ID, and this is the length of the data, which is 2 bytes, and then we have the data. But we will not focus on this. We will go on the hardware itself, okay? I'm just giving a run through, okay? So let's go back on my presentation. And if you want to try a unified diagnostic services server or an ECU simulator that is not hardware-based or a software-based, I provided the link for the UDS server. If you're gonna run it, it allows you to, emulate an ECU that wherein you can actually send UDS or Unified Diagnostic Services. And if you want to install some car hacking tools, I provided the link as well. It's by Jay Gamblin or Jerry Gamblin. And I'm sorry for the rooster that you can actually hear. I'm that Filipino wherein you can hear roosters on the background because we have roosters near my house. Anyways, they've been appearing since Bugcrowd Level Up, and yep, they're always here. Anyways, all the scripts are designed to run on Ubuntu, Kali, and Debian. So they can be installed via the repo, the link below. And then, I've already provided some links on the software side. So we want to get to know about the hardware, right? So let's go. These are my favorite tools. This is the NanoCAN from the left side. And then we have the CAN-TAC. And then we have the TechMaker made by my friends from TechMaker. We have the STM32 CAN sniffer. And then we have the Value CAN 4. Okay. Now, the devices aside from NanoCAN, these devices cost more than $50. Okay. We want to focus in creating our own sniffer for just less than $50. Okay. Now for NanoCAN, you're just gonna spend $5, and I'm gonna teach you how to create your own in this topic and in this presentation. I mean. So, but before that, we want to have our own hardware, right, to test. And for just $20 in eBay, if you're gonna buy a PG207 instrument cluster speedometer, it's gonna cost $20. Okay, you don't need this one. But if you want to go full blown, you could actually buy 120 pounds ECU kit if you want to build your own test bench. But for beginners, I think you're gonna have to start with a PG207 instrument cluster, which costs $20, and I actually have it here in with me right now. But we're just gonna, because it's really hard to put in the camera, but I'll show a video about it. And if we have more time, I'm gonna turn it on. Anyways, yeah. So yeah, it's really a starter pack. You need to determine the pins of the cluster, and you know what? I'm gonna show the cluster right now. So uh, from what you can see on the video, you have the NanoCan, and it's actually trying to fuzz the cluster. So this is my cluster. I'm not sure if it's actually clear from your screen right now because of the virtual background, but this is the cluster that I'm talking about. And then at the back, I've already Pinsonet, my mentor, actually put lines on the pins, and I soldered it with the can, and then with can high and can low, and then I already put OBD2 connector to it so that it's easier to plug in with some of the devices that I have. Right. And then from the right screen, you have there an ECU simulator, which I bought from Tindy, and it actually costs $100 something. I think it's $100. You don't need this one. It's just for simulating things. And actually, you can't sniff on it if you don't send UDS messages on it. So it's not real-time hardware. Okay. And then because this is what we want to focus, right? We want to build our own $5 can hacking tool. So meet NanoCan PCB by Mintonet. Okay, it's a $5 car hacking tool. Okay, there's a PCB right from the screen. Okay, what you need is, I've actually have this as one as well, and if I could, if you could see me in other conference, I provide some of the PCBs which I custom made. And if there's a problem with that, you could also go to mintonet/nanocan, and then you could prototype your own from here. Okay, you just maybe spend on JEL some prototypers, because you already have the sketch for this one, the PCB design file. So you could prototype your own PCB design file with this one. And if you try to open the editor, you could already edit this one. Okay, so, and you could also put your own name on it. Okay, but and in fact, but you need to ask permission from Mintonet for you to be able to do this. Okay, and then after that, you need to just prototype it from your end. Right, next up we have you need these two components for you to solder it, for you to have your own CAN hacking tool. So you need an Arduino Nano and an MCP2515 module. So you're gonna need to solder these two together, and then you know in the GitHub file that I provided, it's complete already. okay, on how you can do it. And then if you want to have the additional component, so you need to have, you need to attach the CAN high to pin 6 and then the CAN low to pin 14. And then I've also provided sample code or sketch to the Arduino. And this is actually how you're going to do this, okay? So if you have Arduino running, yeah, it's still loading, sorry for that. Right, before that. Right. So this is a sample fuzzer that I've actually made for my own. It's a PG207 cluster fuzzer, and this is a sample sketch that I have. But if you want to start first, like this is your first time running the Arduino IDE, you need to download this one first. You need to download the zip file and then download, just click on download the code here. And from there, you need to go to manage libraries. No, it's not manage library. Sorry, I made a mistake. You need to, should call this, you need to include the library, okay? Uh, go to sketch and then include library and then add the zip file. And I've actually added mine already, which is the MCP CAN lib. And by that, after that, you can already see samples like how you can actually send uh, signals to the CAN. So take, for example, this one. This is a sample sketch on how you can send messages to the device or to the controller area network. And you just need to define the CAN bus speed. So in my case, it's 500 kbps. But because we're using the PG207, it's gonna be 125 kbps. And then the baud rate should be 115200. And then from this, you're actually sending the CAN ID 100, and then this is the data that you'll actually be sending. All right. And then you can also create your own sniffer, which allows you to actually sniff, okay, what's going on with the device. So from here, you could already try to sniff what's going on with your hardware, okay. All right. I'll show a video on this later on. Let's try to continue on the topic. So yeah, if you could spot me or Mintonet in a conference, if you're interested, just ask me. Ask me one. I actually have the root conversion, which is a blue PCB, and also some additions to it. And Mintonet also has a different version that he has. So what? Another question is, what if you have this? Because some car owners actually have this ELM 327. So can can you actually use this for car hacking? Yes, you can actually use this, but it's actually kind of slow. But if you want to try it, you could actually use Metasploit. If you go to the Metasploit tools hardware, you need to use RFCOM and then the ELM 327 relay. It's a Ruby script so that you could interface your ELM 327 hardware, which costs $5 to $25. And you could actually, yes, this is a sample. Basically, this is a literal car hacking on a chip, thanks to Craig Smith, because Hardware Bridge is made by Craig Smith when he used to work at Rapid 7. And actually, I've provided or contributed some modules as well from this. And as what you can see here, uh, Hardware Bridge is open, okay? After connecting to the ELM 327 relay, I provided a script which I made. So if you have a a hardware bridge that you have, or if you are connected to the CAN already, or if you have a virtual CAN, you could use my hardware bridge connect resource script. It's I've provided some of my scripts under RootCon Labs, and I've also provided my module for basic car hacking and the Metasploit. So it's just a simple sketch, I mean script, and then my sketches are actually here. Okay, if you want to try on the sketches that I've made, it's here for Arduino. But for automating your Metasploit, it's here, the hardware bridge RC. So you just need to, let me just try to give a sample on that one. Okay, let's try to open up the hardware bridge. So okay, we have the hardware bridge script right now. So what you're going to do is you just need to type in MSF console -R and then the hardware bridge script. Right. We don't need that one. Okay. So it will fire Metasploit and yep. And then we have a session. Okay. If you try to go to sessions, you are connected to your hardware. So if you try to use that session, there, you are connected to the hardware bridge session. And you could already do a lot of things with this one. Take, for example, do a bus config. You could also send CAN using just the ELM 327. Okay. But anyways, that's not one of our main topics. It's just, an overview that we have. So let's continue. Yeah, this is the module that I made. It's for the Mazda 2 instrument cluster. I also own a Mazda 2 car, so that's why it became my target. So let's try to have a demo on actually the junks that I have. Right. So we have a can in the middle. So I'm actually using NanoCan to fuzz my instrument cluster. All right. So this is the PG207, and also trying to send messages via the CAN-TAC. So that's why you have I was able to sniff the packets that was sent by my NanoCan because I have two wires connected as a splitter. And then this is my Mazda 2 instrument cluster fuzzer. Um, so with just a $5 car hacking tool, I could already play with the CAN. Okay, there you go. All right, and then I just like to show if you're interested with with a good tool, really, like it's not $5. I just bought P1 machina. It costs like I think. Let me try to search for that one. Okay, machina P1. All right. Right. So you have a fully featured computer, which is P1, and this is actually a demo that I made from my other car, which is the Toyota Hilux. All right. So I connected it to my car, and started sniffing the packets on the vehicle using CAN dump. And there you go. So what you can see, this is the CAN device, the config, and then the arbitration ID, and then the length of the data. So it's kind of noisy because it's a pickup truck for Toyota Hilux, and I'm pretty sure that you also have this in Malaysia. So, but anyways, if you want to start small, this is the best way to start. Okay, you have this one. This is the really the best way, and I think that's actually it for this one. Because we have a short time. If this is a session, we're gonna really gonna make it in depth. But for this one, because it's a short session, I'm just making it fast, kind of fast, and make sure that I've tackled some points. Anyways, what's next? I'm gonna give credits actually to some. Sorry. Yeah, we're done with the demo. I'm gonna give credits, of course, to the Car Hackers Handbook, to Nanacan from Internet, who is my mentor. Getting started with car hacking. The carhackingvillage.com/getting minus started gives you an overview on how to use CAN utils, and then CAN Bus Basics with Hands-on Fuzzing by Ian Tabor. This is the reason why I started with. He's the guy behind, starting with NanoCan and also with clusters, playing with clusters. And then I would like to give a shout out to the Car Hacking Village, Craig Smith, Ian Tabor, Car Fucker. He is the founder of the Car Hacking Village. His real name is Robert Neal, but I like his name, Car Fucker. And then we have Fronders. We have TechMaker UA. They were the ones who gave me the STM32 can sniffer. And then we have the ASRG, Automotive Security Research Group, and the ASRG SIN from Singapore. And then we have Spectres, Jammy, and Semprix. Jammy is my co-founder of the Car Hacking Village, and Semprix is our godfather of RootCon. So he supports us in trying to make car hacking village in the Philippines great. So yeah, and also he tries to teach us as well with some of the basics. So now I'm open to questions because I'm almost time. So we have like 2 minutes left. No, let me try to get that. I think I'm open for questions now because we only have 40-minute topics, 40 minutes for the topic.
Okay, hi Jay. So there's two questions so far.
Okay.
So the first question is, couldn't you hack internet connected cars, as some of them do update their firmware from the internet, as well, especially through the infotainment system?
Yes, you can actually do that. Like I said, it's one of the attack surfaces, but it's not that easy right away. Unless you connect your infotainment to your Wi-Fi, or unless your infotainment has there's a telematics unit on it, so you can actually do that. Okay, you can update the firmware or change the firmware on the fly, but it's not just that easy to do. Okay, you need to be connected to it. You need to be on the adjacent or network for you to do that. So because telematics allows you to connect to the Wi-Fi, yes, you can do that. In fact, you could also SSH into your car. I've actually tried that in my Mazda. For Toyota Hilux, I haven't been able to SSH into my infotainment yet, but for the Mazda, I was able to do that. Um, I actually can't disclose some of the things that I've did for Mazda because maybe they will try to sue me. So I was the reason why Mazda parts patched their car, and I met them during DEF CON 25, I think, and they gave me their car and they said that I was the reason why they tried to patch some of their infotainment system. So you need to Jay, you need to end your share screen for you. Yep, I already ended my share screen. Okay.
I see. Okay, so the next question is, if it's in the real world situation, how long will it actually take to gain physical access to the vehicle and like drive it away?
Right now that's kind of hard actually. To tell you honestly, that's kind of hard. There's a demo with Cossack B, the one that I've talk about Tesla. So it took time because you need to have a hardware. Unless he has a hardware ready, and I pretty much guess it's about 10 minutes if he already has the hardware. But if not, you're gonna start from scratch. It's gonna take time because you're gonna need to pair the key fob and keys, and then you need to have an extra ECU that you're gonna plug into the car, or what? There's another thing. Um, Take for example ripping off some of the components, like for example the brake light system, which is under your car. There's a two CAN there is a CAN bus wire there, but I'm not sure for other cars. But there, I can't disclose what car is this. They're gonna sue me. But in a bug bash, someone was able to do that, wherein he was able to unlock the car by ripping off. I mean, he was able to start the engine by ripping off the brake lights and send CAN bus message to the car. And then he also made an ECU reset for the car.
So basically, we can expect that in the future, as more and more cars have this system in them, we will see more and more of these attacks, and more cars will actually just be stolen from these type of attacks.
Actually, there's a lot of, not really that much, but there are more attack surfaces. But it doesn't mean that it's easier to steal cars right now. Automotive companies have started beefing up their security of the cars, so it's not just easy. I mean, you can do that with older cars, but even though it doesn't have internet connection, like you can just replay the key fob keys right away because it doesn't have a rolling code. But right now they have rolling codes, and then from time to time, if a vulnerability has been found, um, they have over-the-air updates right now for most cars. In fact, Tesla is actually doing an over-the-air updates right now because of what Leonard actually discovered for Tesla. So it makes hacking kind of harder right now since 2018. Remember, like I said, there's an SGW security gateway, and if you can bypass that, then that's an issue. All right. Someone was able to bypass it last year. Okay.
I see. Okay, next question. It says, question from a beginner. How do you how do you find a balance between investing in cheaper learning tools and investing in a real vehicle? Car prices are different countries.
Yes, car prices are different, right? You don't need to buy an actual car for you to do that. I mean, in the Philippines, we can buy cars cheaper actually here. We could also buy test benches. If you're not from the Philippines, you can just go to eBay and search off some of the parts. It costs like $100, $120.
Wow.
So question, there's another car prices are different in countries. I agree. Singapore has a very expensive car price, but
Mm,
ASRGSIN were able to buy some test bench as well, and they presented them to other conferences.
I see. Okay. Another question. Uh, can the OT updates be hijacked as well?
Uh, yes and no. So right now there's what you call firmware checking, and then some cars have patched it, but there are old cars that can be hijacked if it's very old. You know,
I see.
it's not for
Okay.
all. It's not just that easy to do that. But yes, it is plausible. And if you, for example, if you are able to hack the PKI bridge, or if you are able to hack the web server where the OTA updates are coming from, then yes, you can.
Oh, I see.
SQL
Okay.
injection, and then you change the firmware.
And that's why you need to always clean up your SQL statements. So that's the last question. Jay, any closing remarks?
I would like to thank NanoSec for inviting me here. I think it was Belinda who actually told me to pass my paper, and I hope that I could go back next year and bring out some of my car hacking friends as well for your conference. And did you had any car hacking village in NanoSec yet?
Um, no, not yet.
Not yet. I think I'm gonna invite some of my Singaporean friends and some of my Filipino friends who are into. If you are planning to, yeah, we could
Yeah, I
start.
mean, we of course we wish that we can start one here. Yeah, yeah, definitely.
Okay, yeah. Do let me know on that, and I'm always I could always start one. Help you guys.
Okay, thank you, Jay. Just want to say, our audience were loving the sound of your rooster in the background. I mean, or your lunch, or or both. I don't know. I'm just kidding.
It's not my lunch.
Anyway, anyways, we're gonna take a 2 hour break now. Yeah, 2 hours. Like it's gonna be enough for lunch. It's gonna be enough to deploy a Firebase, but definitely not for a Windows update. See you at 2 p.m.
All right. Wait. Is there there's another talk for that one, right? This is my
Yeah,
last
yeah,
talk.
yeah. There will be.
Okay. Thank you. Bye.
Hello.
Hello.
In this presentation, we'd like to
projects for over 15 years. His main interests are network traffic analysis, incident response, botnet, and cybercrime investigations. You can see him at conferences such as FIRST, CARO, HITB, PH Days, Zero Nights, POC, HitCon, Black Hat EU, and many others. Please welcome Fyodor and Vladimir.
Hello.
Hello.
In this presentation, we'd like to dive in a topic of compromised assets and discuss who really owns your servers, you or the scavengers of the cybercrime. This presentation is going to be delivered by me, Fyodor Yarochkin.
And me, Vladimir Kropotov.
We are senior threat researchers with Trend Micro Research.
We are not going to spend a lot of time to discuss in our biographies because everything is available online.
Let's spend our valuable time discussing the actual topic of our presentation. So who really owns your servers? Have you ever wondered? The servers that you spend money on, buying the hardware, maintaining, upgrading, and paying for its internet connection. So who really runs software on the machines? In fact, access to both servers, dedicated servers, and machines within corporate networks is a common tradable good on underground forums. We often see posts like this when a person offers access to a large corporation without giving much details of what corporation is. He describes the network environment that he discovered, the amount of the data he identified, type of assets that he managed to compromise, and of course the price. For illustration, he often includes screenshots of compromised machines or other devices, such as web cameras, and this indeed makes this offer very attractive. Have you ever been wondered if your corporate network or the machines that you run have ever appeared on such sale or would ever appear on such sale?
Anyhow, it's a disaster for InfoSec team if it happened.
In fact, automation of credential verification is very accessible to cyber criminals. Credential reuse is a massive problem, and with large amount of recent data breaches where large number of credentials been leaked and currently accessible to the attackers, it's a growing significant problem. And there are a number of tools exist which help attackers to test and validate those credentials against variety of services. So if any of thousands of employees within your organization happen to use the same username or a similar username and a password for his personal web forum account and a corporate account, your network might be compromised. And what is the source of such data? Cloud of logs is a new growing trend within underground service providers. What essentially is being provided is access to logs of keyloggers, stealers, and other data collection tools. You could either buy queries through those data sets, or you can buy access where you could run the queries yourself. This allows attackers to use stolen compromised credentials more effectively, targeting larger number of organizations at the same time. So let's look deeper into a life cycle of a server that could be potentially compromised.
And here we will illustrate what normally happens with server at the later monetization stages. So in our recent research, we published it in October. We have a categorization of bulletproof hosting, and different types of assets are used for this hosting. And if you go to the right side of this picture and look, you can see how cost of the service drops down from the bottom. Servers in own criminal data centers. In the middle is short-term lease. And on the top, we can see the cheapest price for the hosting on compromised assets. And this hosting is widely used by criminals when we operate and accomplish routine operations with objective of monetization of the knowledge we have and accesses we have. Of course, since it's a cheap access, where are some drawbacks. So normally it's no uptime warranty, and this kind of hosting is suitable for limited type of activities, which normally have a short time span, like hosting of phishing pages, like sending spam emails, or vulnerability scanning and brute force attacks. In this case, if asset is alive during the night, it's normally enough for criminals to get the money which we paid back and earn some extra money on top. Hosting is just one of the options of this kind of monetization. And let's look what else we have. If I look into recent news about different types of malware, we can see a prevalence of news headlines related to ransomware campaigns. Many companies witnessed this kind of attack. If we look into this news, we can find that ransomware is just one action. Even ransomware groups actually exfiltrate the data and we blackmail victim. The data we had stolen, and some groups already publishing the data which we exfiltrate from the company. What else we see? It's a coin miners which are distributed over government and corporate networks, where many other stages which we will discuss right now. What happened with server or compromised asset, which could be a corporate network or government network? We're not limited here us to server only scenario. On this diagram, we can see what Mehta actors can do asset categorization and estimation of possible monetization paths. What means that it's not like before when compromised computer was a part of the botnet and all thousands or tens of thousands bots consider it the same and the value of these bots was the same. For now, like APT groups, criminal actors categorize assets and trying to find the most important assets like computers inside corporate networks, computers inside banks, or other critical infrastructures. And those assets like diamonds, what means we can sell these assets not for tens of dollars, but for tens and hundred thousands of dollars on the underground market. Where several other scenarios which could happen after compromise, and which scenarios can be repeated by different owners. But normally, if before assets stayed in one hands for quite a long period of time, now it's normal to resell access to the asset on the underground, and this asset could be sold to APT group which will monetize the asset APT style while leaving traces of mass malware campaign, or sell to underground actors and criminals groups who will monetize this asset several ways. What we've seen is that coin miners, which are normally considered as low priority threats, often just an intermediate stage of monetization of more complicated and dangerous scenarios. And that means that infrastructure owners shouldn't treat coin miner, which we found on the asset, as only one disaster that happened with the computer, server, or network. That means there could be many changes of hands on the background before and after, and the scope of incident and the impact of incident will be way worse than expected. What is obvious that a ransomware attack is often a last stage of monetization because this attack is pretty visible to infrastructure owners. And that means that discovering ransomware in the network, this could be just the last stage because we saw explicit advertisement that criminals selling access to corporate networks, which were monetized by many types of methods before, and by explicitly selling those accesses for encryption.
So to summarize, once machines are compromised, while the attacker is waiting for a machine to be sold, he could be running his own software that makes him a little bit of money. However, once the asset is sold, or even before it's sold, the data could be exfiltrated, access to particular devices, or the data could be sold. The data itself could also be sold. And then the operations that make an asset inoperable could happen, such as ransomware. Typically, an incident discovery happens only at the last stage, because once machine is taken for ransom, many of the applications no longer work. But it is important to be aware of this life cycle and try to be able to detect and prevent further escalation of the hacker activity at early stages of his activity. Before asset is monetized at the final point, there are many other ways how it could be monetized during the intermediate stages. A compromised server could become a part of the Fuzzflux network, a short-term bulletproof system, a proxy, or a reverse proxy that could be used by some criminal groups to conduct their malicious activities.
And that's why sometimes you can see what computers or servers of legitimate networks are among the list of C2 servers or was visible during our malicious campaigns.
It's important to understand the full context of incident. A single instance of compromise within a network could mean that the compromise could be further escalated and attacker might move laterally to gain access to additional resources on network, which could be later sold for further abuse.
To summarize, assets before ransomware attack or before any other suspicious activity which was detected by incident response team or SOC or CERT can change hands many times. And it can be treated as a random asset as before or as a categorized asset, which is way more dangerous. It could be sold to APT groups. It could be used as a proxy or to commit other types of malicious activities and attacks against our organizations and end users like fraud. Of course, data exfiltration is often almost compulsory step for this kind of compromised monetizations. At the intermediate stages, criminals sometimes or often monetize with coin miners, and we can see a ransomware attack at the end. And of course, it could be a targeted ransomware attack or just a mass ransomware campaign where criminals not consider the cost of particular asset. And of course, many steps, except probably the last one, a ransomware attack could be repeated several times, as long as it gives money for criminals or opportunity to monetize access to infrastructure.
So as an OS hacker, the first thing you probably would do, you come to the market for shopping. So let's briefly look at the market from the perspective of an OS hacker. An OS hacker probably knows how to use a famous search engine called Google. He can come to Google and start typing in searching for dedicated servers. Surprise, the first things that come in are either online websites selling dedicated servers, often often based on compromised assets or created using compromised cloud credentials. Or he can find an advertisement on a social network where a threat actor is selling dedicated servers based on compromised assets. Of course, he would also find links to online forums with sections that purely dedicated to trade of compromised assets. Let's quickly take a look at one of such forums. You can see that there are multiple advertisements of selling dedicated servers with a guarantee. Since it's a compromised asset, the person cannot guarantee that this asset will not be taken down because he does not physically own the machine. However, he can provide a replacement for a server that might suddenly disappear when sold to a potential customer. Since most of the purchases of such servers are short-term, so this kind of guarantee does not significantly impact business operations of those customers. And the price is extremely affordable. As you see from the advertisement, a single machine goes for $2 per day. Many of those forums could contain up to several dozen pages covering advertisements for buying or selling compromised assets. You could see that variety of assets are available. You could see virtual machines. You could see instances of virtual machines created on cloud platforms. You can see access to variety of services such as RDP, VNC. You could see access to parasitic computing resources such as hidden VNC, and many, many more.
And you can see tens of pages of discussions, tens of thousands page views, and in some cases more than hundreds of thousands page view for the particular topic.
And of course, cyber criminals are fast adopters of innovative technologies such as online messengers. Telegram and other messaging platforms are also a common medium for selling or distributing information of stolen assets. For example, there are Telegram channels where you could find credentials to compromised machines either given away for free as a gimmick or sold for a fee. In fact, there are also bots which operate this kind of sales, and it is possible to complete the whole operation of purchasing a stolen asset completely through interactions with the bot. On the screenshots, you could actually see that once you start communicating with the bot, you can select a category of asset that you would like to buy, either an RDP server, a vServer, a credit card, a NordVPN access, maybe dumps of cookies from Google and credit cards, passport scans, and lots of other things. Once you select category that interests you, you can drill down and complete your purchase. So many hackers do not like to operate within the country where they physically reside. That's why you see many offerings that sell assets have particular interesting exceptions. For example, this seller sells dedicated servers worldwide, with exception for former USSR countries.
And you can see what warranty in this case is 12 hours, which indirectly indicate which assets are based on the compromised assets. And warranty here is just 12 hours, and you can barely consider so short warranty for legitimate resources. And that means that with RDP servers were compromised and now sold on the underground.
Other offers sell dedicated servers and VPN accesses. You can make a careful selection by country or level of access to the server. Sometimes you might want administrative access to machine. Sometimes a single bounce point is good enough. The country where the server is resided is very important because many of other criminal schemes require location of asset to be within a particular physical geographical location.
Compromised servers, it's not the only asset. We can often see when anonymizing services are provided on the underground based on compromised assets. So here we can see SSH tunnels with warranty 72 hours, where the price depends on the number of assets which has been purchased. And that means that criminals using hundreds of tunnels to commit their tasks at scale.
As we mentioned, because many of those assets actually based on compromised servers, so the attackers can provide only limited warranty after the purchase. And of course, if the person who buys the machine modifies any of the system settings, warranty is voided. Some of the sold assets are based on non-conventional hardware. For example, we've seen sellers selling access to IoT-based infrastructure. So let's look a little bit more into how the assets are compromised, collected, and maintained by threat actors.
There are several ways how criminals compromise servers. We can use stolen credentials or cloud of locked services. We can steal and use access to API keys and cloud management consoles. We can use vulnerabilities that we have. We can compromise credentials using brute force attacks or phishing attacks. So there are many ways, and let's see examples here.
So as we said, a server similar to Cloud of Logs exists. And there are multiple ways how attackers monetize access to the server. In this case, we see a person offering his customers to run queries through his logs. And he details a little bit on what kind of data he has or does not have in his dataset. Like he does not have access to email accounts, he doesn't have access to cookies. A search for a single URL credentials would cost you $2, and geographical location is the whole world. As we published in the article that we've written recently, many of those services actually provided through a customized specific platforms. Those platforms often promoted on online forums, so it's not that hard to find their location. You can see clouds on the illustration, as you see. And we took a quick peek at those platforms. So let's look at them. This screenshot shows one of the systems which was offering trial access to the platform. You could see the amount of data they have on the platform, over 3 terabytes of the data. You can see number of total what? So multiple sources were used to create this data set. On the screenshot, you can see 2,568 different sources which contributed data to this cloud. There are more than 652 users who have access to this data set. And you might wonder why the number of users is important. For the attacker, it is important because it tells that there are more than 600 people that simultaneously look at this data. More people examine the data, lower the quality of the data.
Sellers of such services, to address this problem of parallel access to the data, we introducing quotes, which could be a quote to the number of search queries per day, results of which buyers can download from the platform.
And on the bottom of the screenshot, you can see the data update schedules. Of course, it's important for the user of the data to know how often the data is updated, because you don't want the data that is not updated at all. It will become stale and old very soon.
So normally we can see advertisement about weekly or monthly updates or updates 2 times a month.
If you drill down into this data set, you can see more details of what kind of data is available. You can see the different data sources, breakdown by type of data, geographical locations, and other characteristic of the data that could make a difference to the actual user of the data set.
And among types of data were financial data like e-wallets, access to Amazon or other internet shops, crypto wallets, credentials related to social networks, and of course, credentials related to corporations.
This is a screenshot from another similar platform. The screenshot details that they have 48,621 passwords available and over a million different cookies available on the system. Of course, they sifted through the data. They identified some of the credit cards, some of the Bitcoin wallets, and they also have geographical location that breaks down by source of the data. Very interesting.
And what is unusual for this particular seller, we have a lot of data or credentials related to South America and Asian region. Because the most interesting credentials for criminals are normally located in Europe and in the United States. To summarize this topic, we made an analysis of offers on the underground, and here is a summary of several out of many sellers who offer this kind of services on the underground. We can see that data is measured either in number of records, which is not related to number of passwords directly or to number of cookies. It's a number of compromised assets which has been used to collect the data. So for every line out of 100,000, there might be tens of passwords and cookies inside. The price model is different based on several things: size of the data, the quality of the data, what means if data or logs were monetized already several ways before, because often sellers selling access to the data, which was, for example, already monetized for e-wallets and Bitcoin wallets. What means that value of this data is a bit lower comparing to the data or logs which was just collected. And we can see the prices, which normally varies from $100 per month up to $1,000 per month, or several $1,000 for lifetime access.
So as we mentioned, a level of access to compromised credentials is extremely important. One of the examples was discussed in blog post published by our research team on Ryuk ransomware distribution. As you can see, one of the TPs of Ryuk ransomware distribution is once the access to the AD server is gained, they are capable of pushing ransomware to the workstations which are connected to the same domain. On the screenshot, you can see an example of PowerShell script that was extensively used to move laterally to their targets. How do they compromise AD controllers? Of course, everyone has his own tricks, but if you don't happen to have tricks, there is always a service available on a forum where a person might offer you help in compromising AD controllers or run other types of pen testing services against your targets. Of course, use of vulnerabilities is also a popular means of lateral movement across compromised assets. And we see this in distribution of Ryuk ransomware as well. Some of well-known but not patched vulnerabilities, such as Eternal Blue, has been actively used in some of the RUK campaigns that we observed within compromised networks. Reuse of harvest credentials is, of course, another means of moving laterally within networks, as we discussed previously. And of course, that kind of network is itself a sellable asset. We can see that a person is selling access to a company in Europe. He details that the company has annual profit of X. As you can see, some people simply practice compromising small and medium companies and selling them in bulk. This particular person is offering access to multiple companies in Europe, which he managed to compromise. In some cases, he managed to gain admin access. In some cases, he did not manage to gain admin access, but he's selling them in bulk or offering a partnership deal where he is ready to accept 50-50 profit share for rising privileges or running software on those compromised machines. Some of the other sellers managed to gain initial footprint on target networks, but they're looking for a penetration testing specialist, which would help them to rise their privileges or move deeper inside or laterally through compromised networks. Of course, service like that also exists. There are people who offer services and software to run brute force attacks for credentials and provide the results on compromised credentials. This person mentioned that he already has a number of credentials for such big sites as Walmart, Bandcamp, HomeAway, WordAboutTrip.com, and many, many others. And of course, penetration testing is not limited to technical capabilities. Some of the sellers also offer social engineering services in addition to the standard package, while offering penetration testing services.
And it is important that some actors, when it's really necessary, combine quite interesting social engineering approach. So we send in malicious email, for example, or email with a link to a phishing page. And at the same time, we are calling victim, and by default, we are social engineering victim to click the link or open attached documents because of its importance.
Yes. Let's follow up and examine a single step from our life cycle of a compromised asset using the following example. On this screenshot, you can see a poster offering access to a big Germany energy sector company. Please pay attention on the date. The post was made on 10th of September. The person is offering RDP access and TeamViewer access to more than 50 machines within the target network. Price is not listed within an offer and could be obtained by sending personal message to the seller. The next day, 11th of September, the asset is already sold. This shows how fast the business could happen on those forums.
And as we saw on our advertisement, the cost of an access for big critical infrastructures could be measured in tens or even 100 Bitcoins. So that means the price, which is over $500,000 US, are often discussed on the underground.
And of course, there are payoffs because the ransomware gangs could easily make up to few millions from a single compromised company if that company decides to pay. Since the attackers operate at larger scale, of course, they start developing tools and environments to scale their operations. On this screenshot, you can see an offering of a tool that allows you to automate processing and analysis of the logs called SorterX. This tool is capable of dealing with a number of log formats used by popular keyloggers and stealers, such as Azarult, Potato, Crot, Smoke, and others. In the other slide deck, the person is offering a tool to run credential checks for popular websites.
And we can see as an output of this tool, account which was successfully verified and the status of account was a premium or free account.
The tools are customized to be aware of the context of the website. There are other tools, such as Stellar Log Searcher, available, which are also capable of handling variety of log formats and allow users to quickly search and find credentials quickly and swiftly through a large amount of data.
User can choose a folder with logs, which considered to be in text format, and use particular terms and determine the scope of the search. As an output, user will get normally list of credentials related to a particular domain like PayPal or Amazon or Google Cloud, or if search is more complicated, the user can get back a list of the accounts related to a number of social networks or corporate accounts.
There are a large ecosystem within trading and sharing configurations for some of those automation tools, such as OpenBullet. On these screenshots, you can see a user demonstrating a use of the tool for the account verification. This tool is a very legitimate open source tool, available for free to download with the source code and has a legitimate use as well. However, there are configuration files customly created by online forum members for credential validation against different resources. If you search for occurrences of discussions for this tool on some of the forums, you can actually see that most of the threads actually threads about sharing and trading configurations for the tool. Configurations allow you to customly run credential checks on a number of services, including online TV services, online forums, online shops, Burger King, and lots of other shops. You want a pizza? If you manage to get credentials for Domino's, you get a pizza. That's the script kiddie primary means of using those configurations. And of course, being script kiddies, they don't even read what they buy or get access to, often being tricked into also revealing the data that they getting access to. On this screenshot, you can see a person selling access to Azure accounts.
So, and what does it mean for the owner of this account?
Cloud accounts are the big hot sale because once you have an access to a cloud account, you might actually start creating instances of virtual machines, which might not be even charged to the actual account if you terminate them timely.
But the thing is, these accounts are sometimes appears inside corporate infrastructures. So that means that's yet another way or opportunity for criminals buy access to this kind of console or to the machine generated with this kind of console and be inside corporate infrastructure.
Think of it. The threat actors may not only decide the kind of virtual machine they're creating. If cloud account belongs to a corporate network, a corporate owner, he may actually also decide the subnet which this virtual asset would be connected to. If he managed to identify a subnet that is located within the corporate internal network, he will create a virtual machine that will instantly provide him access to the internal network. And of course, my home cats seeing other cats selling cloud tools are very vocal about this. I think they're complaining about me talking other cats selling access on online forums. Selling cloud computing accounts is indeed very common and is extremely affordable as well. Google Cloud accounts that normally run for 400 US are only sold for $15. AWS Business Plan goes only for $10. Azure, the same price, $10 for normal accounts that have $200 or more in balance. Other hosting platforms such as Linode, DigitalOcean, Vultr, Jonas also go for the same price. And of course, during the incident response investigations, we often see hacker infrastructure offering using machines from these providers. And the last note that we would like to bring attention to, we are the watchers of the cybercrime actors, but the cybercrime actors also watching us. On the screenshot, you can see that they actually monitor themselves, and if anything pops up on Twitter, it might get reflected on the forum as well. So for the sake of creating less disturbance, we would appreciate if no screenshots from this presentation are taken and posted on Twitter.
Based on the topic we just discussed, how this affect attacker attribution, how this affect attack mitigation and investigation. Landscape changed, and for now, it is normal to see several criminal groups working on the same compromise, either together in parallel, with splitting tasks in advance, or one by one, leaving traces of many attackers, but with traces could be related to one incident, or these attackers can act in parallel without knowing what both or several groups are present at the same time. So attacker attribution gets way more complicated now, especially if you think about life cycle when compromised assets were sold to APT actor, and APT actor can do industrial espionage while having traces of a mass criminal attack campaign as an evidence of this attack.
So what's the best strategy to defend against this type of criminal activity? Let's look into some of key bullet points. Attacks happen faster. Incident response is always a cat and mouse game with the attacker. With the attackers gaining extended access to clouds of logs and are capable of leveraging power of clouds to make their attacks more efficient. You have to perform your detection, incident response, and mitigation at much shorter time frames. The game intensifies, and you have to be faster than an attacker. Accurate incident categorization and prioritization of identified threat activity is extremely important part of successful incident response procedure. You have to be able to cross-reference and correlate logs from your multiple endpoints, firewalls, intrusion detection systems, and even cross-vendor hardware and software that could give you visibility of what's going on the network.
Prepare your visibility for incident response in advance, because as long as incident happen, it's too late to collect logs to reproduce attacker actions.
If you use clouds, the cloud convenience also comes with additional threats that might be posing towards your organization from the use of cloud platforms. We describe potential attack scenarios that could be utilized by the attackers, but they are not the only ones. Your main valuable asset is actually your data. If your data is placed in the cloud, you have to ensure that your data is properly guarded using the tools and frameworks provided by your cloud platform. With this, we would like to draw some conclusions from our presentation. Attackers are being as innovative as ever. Sale and resale of access is a hot developing market that is being fueled on by utilization of cloud technologies. Attackers becoming more effective at conducting their attacks. They can run larger attacks at bigger scale. They can run simultaneous attacks on multiple organizations, and the prices for the compromised assets are going down, creating additional intensity on the attackers trying to make more money.
And now several groups which
So
contain
go directly to
experts in particular monetization paths are attacking your networks
Right.
instead of
So we
one.
have, two
So you have
questions
way
here.
less time to react, and the impact of these attacks is way higher. So you have to prepare in advance and be ready to detect attacks at early stages, investigate attacks, and do effective attack mitigation.
The cat and mouse game becomes more intense than ever. So good luck winning this game. With this, hopefully you enjoyed our presentation. Thank you very much for attending our session. Hopefully we have some time to answer your questions.
Thank you very much, and we are ready to answer the questions.
Okay, now let's move to the Q&A. So there's a few questions here. So the first question is, you mentioned that some of the services provided come with little or no guarantees. So on average, how long will these data sets remain their validity?
Okay, so when we talk about guarantee, it was mainly covering availability of the machines, of the dedicated hosting machines. And a typical guarantee would be 24 to 48 hours. So if a hacker is buying a dedicated server that was a compromised server, if the server goes down within the next 24 hours, he can claim another server from the seller within covered price. For the data sets themselves, there is no guarantee on the data set. So like the things like clouds of logs where they search for credentials, it's just a bunch of logs that people search for interesting hits. There is no guarantee that those credentials would work or those credit cards would work. It just, they sometimes say that I used this data set by myself before. I probably took some of the credit cards and used them so they could be burned credit cards, but I'm giving you access to search for that. So for data itself, there is no guarantee.
I
So
see.
I would say for proxies, it's the same short-term guarantee for the proxies based on the compromised assets. And for the cloud of logs, instead of guarantee, actors provide statistical data about success rate of monetization. So when this access is sold in the advertisement, you can see that it was already monetized for example, cryptocurrency wallets and Amazon accounts. And for other accounts, for example, 90% works or 20% of accounts works, so some statistical data.
I see. Okay. So by your research, which regions are most readily available in these data sets, like and services? Regions being the geographical locations.
So I would say because those hosts are mainly used for either hosting or fraud, so they would be skewed towards the countries which they mainly targeting for the fraud. So for example, economically successful countries where fraud is easier to conduct, like United States, Europe, would probably the most available within the data sets. And Asian countries used to be very little seen in those data sets, but with the recent years, I think the numbers are catching up. So from what we've seen, and we actually surprised that like we often see Taiwan, Singapore, Malaysia, China, Japan. In the past, we would not be so often seeing these regions in those data sets. Like especially Japan, like recently there is quite a bit of interest towards that
Yes.
region. And Vladimir, do you have something to comment?
I think actually it's not easy to find something in former USSR countries. I mean, compromised machines. It's possible to find hosting, but many actors doesn't provide services on former USSR countries. Overall, it's Europe and the United States. And I think some Fuzz hosting is presented in China.
Yep.
So, okay, so that's the last question. Do you guys have any closing remarks before we end your session?
Well, hopefully you enjoyed the presentation. If you still have questions, we could be easily contacted either through Twitter or email. I think there should be contact information in our slides that we will share with the organizer. So feel free to get in touch and we'll answer your questions.
Okay,
Yeah.
that's great. I really enjoyed your talk. Vladimir, do you have anything to say?
Yeah, so thank you very much for listening to us. And if you need more details, we have 3 white papers published in last several months on the topic of underground hosting, and we cover more angles about this. So feel free to read if you are interested in this topic. Thank you very much.
Thank you so much, Fyodor and Vladimir. I mean, like, it's pretty scary. Like, imagine that your servers, your password, it's like sold to people through bots. Like, I mean, think about it, like bots, not even a person is doing it. Like, it's just a bot set up by someone to just sell your stuff to people. And then you hear people telling you that it's too hard to memorize different passwords and like small things that can avoid these things. And you know what's harder? Proving it's not you that bought something suspicious with your credit card.
Yep.
Anyways, next we will have Harshit, Agrawal, and Himanshu Mehta for their presentation, and we will start at 4 p.m. on the dot. So let me just give the introduction first. Harshit Agrawal is currently working as a radio and telecom security researcher. He is enthusiastic about signal intelligence, electronic warfare, and telecom security. He presented his research paper at international conferences such as RSEC USA, HITB Cyber Week, ICS Security Singapore, Hack in Paris, HITB Amsterdam, Security Fest Sweden, and the CAN USA. He was president at CSI chapter and vice president for entrepreneurship cell at MIT, where he also headed the team of security enthusiasts, which gave him a good insight into cybersecurity. He's the programmer, researcher, and a believer. He believes in providing something out of the box, though he did hack in the box. So anyways, with him is Himanshu Mehta. Himanshu Mehta is currently working as senior security researcher at Zenith Labs. He's passionate about cyber and telecom security. He's involved in several bug bounties, CTF programs, and is the board member of the EC Council's License Penetration Tester Group. He has been invited as chief guest for several security events like RSEC, ICS Singapore, Hack in Paris, HITB, Security Fest, Info Security, Off-Zone, and our very own NanoSec. He previously led a team of security intelligence at Symantec, which gave him a good insight into cybersecurity. So we'll be hearing from them on the session EWN at SIGINT, Swiss Army Knife of Modern Combat. So we'll be hearing from them at 4 p.m. sharp. Stay tuned. Sorry, just a correction. It will be at 3 p.m. sharp. Okay, not 4 p.m., 3 p.m.
Is our screen visible now?
Let's hear it from Harshit Agrawal and Himanshu Mehta. Please welcome.
Hello. Yeah. So shall we start?
Yes, whenever you're ready.
Yeah, we are ready. Okay. Welcome everyone. Hope you are already attending all the sessions and enjoying this conference. I and Harshit are here to uh, present on a topic which is a little bit sensitive. So, and it is very broad topic. So obviously we cannot cover it in a specific period of time, but we try to highlight few of the specific key areas where you can work on and contribute. So this EW and SIGINT, you can see like we have chosen the topic as Swiss Army knife of modern combat. So we can think of like a modern warfare, like whatever you can think, like whether it is a cyber security or it's RF security, it's hardware security, crypto security, whatever you can come into your mind, everything they, most of the organizations, they are using it for the modern combat. And there is a famous saying like, by Einstein. Before that, I'll say like, if there will be World War III, then it would lead to the end of civilization. And that's why famous Einstein, he told like for World War IV, if I know what with what weapons World War III will be fought, but World War IV will be fought with sticks and stones. And so let me start with something like EW. Let me explain it what it is. So EW, which is commonly known as electronic warfare, it is the use of the electromagnetic spectrum in an attack. So this electromagnetic spectrum might include everything from X-ray to visible light to infrared and microwaves, radio waves, for example. And they are all the same thing, but the only difference is in their wavelength. And when we talk about SIGINT, it stands for signal intelligence. So it is basically as intelligence gathering by interception of the signals. Signals are everywhere in the air, so you can intercept those signals, and whether communications between people or from electronic signals are not directly used in the communications. So this is the intro. Harshit, next slide. So here's Harshit, like his primary area includes RF security, telecom security, and IoT security. And next slide. This is me, Himanshu Mehta. So I also work almost in the same domain as Harshit. Apart from that, I also spent some of my time in the web and mobile application security. And I and Harshit, we share same interests. That's how we collaborated together. Though we don't work for the same organization right now, but we have the same interest. So this is the agenda of our talk. So modern military forces, if you see, they rely heavily on a variety of complex, high technology, electronic, offensive and defensive capabilities, for example. And electronic warfare is a specialized domain which enhances many air and space functions at multiple levels of conflict. This session, we are going to introduce attendees about some of the fundamental electronic warfare concepts, strategy and tactics of signal intelligence, and radars and some of the electronic threats. We will also discuss about, like, for example, if you see the agenda, we are going to cover some of the information operations, brief history about electronic warfare. It is very important to understand the history so that you know like how this emerged and where you can actually contribute to. Then we'll talk about how jamming works. Then we'll give a little focus, more focus on the cyber warfare. Then we'll discuss about multi-domain spectrum operations. Then Harshit will give you very nice case studies about the IED and drones, how they work and how you can protect against those attacks. And then we'll give some glimpse about the future of war, how it might look. and where we can contribute more. Next slide. So this is the acronyms that we are going to use very frequently in the presentation. And I ask you, like, if you want, you can take the screenshot, and sometimes, like, if you cannot get something, like, you can refer to that particular screenshot. Yeah, next one. So, okay, Sun Tzu, very few people will be aware about him, but this quote is from the 6th century Chinese general Sun Tzu, who told, like, it has never been more relevant than in the 21st century. Military operations today are being undertaken via smartphones as much as it is using conventional forces. So if you see, like, today's wars are not fought by tanks, aerial bombers, or daring infantry charges. The battles in the 21st century are fought in the cities, college campuses, internet forums, and social media newsfeed. So you can think, like, nowadays, like a well-timed tweet, for example, or an errant Facebook group, or a seemingly harmless WhatsApp forward, they can hold the potency to be even more dangerous than the artillery fire and airstrikes. So while the above may be considered like a stretch or radical statement, but it does not hold water. Okay, so in today's information dominated security landscape, a man with a smartphone has the capability to organize widespread hate, radicalize youth, manipulate public opinion against a country's own military action, and this might cripple a nation's ability to fight a conventional conflict. Okay, so people are using social media platform also for the same thing. So you can think, like, this information warfare will not take much time for this, but it's important to understand, like, what information warfare is before we proceed to electronic warfare, which is the subset of same. Okay, so every day you will see, like, there is a war taking place on devices you carry in your pocket. We are most certainly at the white hot center of information warfare. Okay, there has been plenty written about this, and I won't reiterate it, but I do want to share that this war is far more aggressive, strategic, and frankly successful than you can ever imagine. This new war isn't about capturing land as in previous conflicts, which we see usually, but instead in this information war, the territory being won is the human mind. So everyone is playing with the human mind in this case. Next slide. So this is a basic image which explains the activities that usually the army organizations conduct in information operations. This is just general picturization. It is not relevant to any particular organization. Okay, so you can think, like, the activities which are mentioned over here are to support the information operations, including acquiring, using, protecting, managing, exploiting, and denying information and infosys. So in this case, like, these activities take place within 3 interrelated components of information operations. So this is basically a picture which depicts the information operations, which contains the operations, relevant information, and intelligence and infosys. And these components operate within a battle space established by the military information environment. So army organizations, if you see, like, will usually they conduct these IO activities as part of a dynamic iterative process to support each component in an integrated full dimensional operation. Next. Next slide, Harshit. No, previous one, sorry. Yeah, so if you see here, like, there are basically 6 things that it shows, like, information operations. It shows, like, it involves, like, acquiring, using, protecting, exploiting, denying, and managing information and infosys, like we explained earlier. And when effectively executed, these critical activities will supplement the human skills of battle command, speed decision making, minimize or eliminate uncertainty, and it will mainly focus on the combat power to help protect the force and harness organizational capabilities. So it's very important for the military to work on these particular skills. Like, first one, like, if we give a glimpse about acquire, so commanders usually they must consider the nature of the information required before allocating resources to acquire it. Like, initial questions which might come into mind when acquiring, like, what in particular information is needed, what is the nature of that information, for example, or how can that information be acquired. And then second area comes the use, how the commander is able to see this battle space through the use of space, air, ground systems to acquire relevant information and provide a current situation. So next one is manage. And in order to conduct full dimensional operation, information and infosys, they require careful coordination and synchronization. So if you see here with guidance issued over here, the staff coordinates and integrates information requirements and infosys to synchronize the critical information flow with the operational concept. Okay, and the operational requirements guide the management of this particular EMS, and the principal functions that require planning and control are basically, you can think of like communication, whatever the communication is happening, intelligence collection, jamming, which Harshit is going to discuss further, and some of them might include like resolving electromagnetic interferences. Next one is protect. So while the proliferation of the information and information technology can be a great advantage, it is also a potentially significant risk that must be accounted for in every operation. Okay, so to protect it, the soldiers and the equipment, some equipments might not be new. Okay, so but they have the significant risk that might be accounted in every operation. Okay, so if you see the increase in importance in today's information-rich environment, so some of the friendly information and infosys must be protected throughout the battle space. So what commander does, he next uses the exploit, and in exploit they try to take the full advantage of any information that has come to hand for military operational purposes. Okay, and the exploitation might involve some of the basic steps like reading the adversary's signals, intercepting the communications, analyzing the signatures, extracting from databases, establishing the order of battle, and taking action to deny, degrade, or manipulate those information capabilities. Then last one is the deny, where they can tell that offensive aspect of IO-C2 attack and makes possible the goal of attacking an adversary simultaneously at all levels of the overwhelming force. Okay, next one. So this image basically shows the different levels of war. We will not go much in details, but basically it contains the strategic, operational, and tactical stages. Okay, so in a strategic level, you can see like as with nuclear warfare, nations may eventually develop IO capabilities like information operation capabilities that are perceived to be principally offensive or defensive. Okay, and at operational level, IO occurs across the full range of operations and are critical to the success of each stage of the force projection. So whatever they are planning, everything is happening at operational level. And then at the tactical level, the commanders, they will try to usually accomplish their missions through combined arms operations. And at this level, IO are often limited in scope. Next one. So in this slide, you will see like we try to explain about intelligence, surveillance, reconnaissance, and target. So the military world is awash in acronyms, if you see, to the point where many civilians, including those with the technical backgrounds, can feel like they need to learn a whole new language when working on defense-related projects. So intelligence, surveillance, reconnaissance, and targeting. As a concept, it is not very much complicated, and once you know it, you can see just how essential it is to modern military affairs. So let's break down each of the components of ISR and T. So first one is like intelligence. So in intelligence, you can think of it as like it is the actual data which is collected in the field by humans on the ground, sensors, hacking or some other means, which is then sent back to the command and control, like which we explained earlier, like C2, for analysis and presented to decision makers. So this is very important step, intelligence. Then comes another stage, which is like surveillance. In surveillance, like you can think of it as like it is the act of monitoring behavior and communications to gather intelligence. And surveillance can be carried out in many ways, like such as audio, video, for example, cameras, microphones, wiretapping, for example. And it might be through like digital, like big data collection, and many more examples can follow. Then comes another one like reconnaissance. You can think of it as like similar to surveillance, but with one major difference. Like reconnaissance is all about gathering intelligence from the field in areas outside the control of friendly forces. So this means like sending human agents, for example, or sensors of some kind into enemy territory to gather vital information. So you can think of like many countries, they try to catch the spies. Okay, so almost all the countries will have their spies in other countries. Okay, so you can think of they are there to do the reconnaissance. And a perfect example of reconnaissance in action would be camera-equipped UAVs, which provide real-time video feeds of hostile territory and targets. Next one is targeting. If you see like as the name implies, the process of utilizing the intelligence gathered to select a target to strike, as well as what weapon systems to use, like whatever depending on the target, you will decide what weapon you are going to use there, because that is what Harshit might be explaining you, like what radars can be capable of, and how you can bypass those things, how drone attack can be done, or how we can protect against drone attacks, for example. Next one. So we will just give a brief history of electronic warfare, because you know, it's been centuries that we have been using this for the war between countries. Like, so if we examine the history, it becomes almost incredible that we would not have anticipated our great social media platforms to be infiltrated and weaponized against us. But if you see, the history proves here one thing, okay, that it is that history repeats itself. History is one way to predict future risk, and you can see like patterns which are emerging that can help us to be wary and mindful of risk. And this information is just one front on which modern warfare is based. So let us see like what are the some of the significant history about electronic warfare, and then we'll go much deeper dive into that. Next one. So we try to highlight few of the key significant incidents, okay, that has happened in the early days of basic signal intelligence, and has covered a wide variety of technologies and use cases. Okay, so if you see, first one is Russo-Japanese War, which happened in 1904, and this is actually the birth of signal intelligence. So you can see it's almost more than a century, you know, more than 100 years back, this signal intelligence already started. So what Japan did, Japan was able to intercept and analyze the Russian naval transmissions, which played a significant part in the eventual Japanese victory. And these first true combat intercepts highlighted both the potential of this new source of intelligence and the importance to secure communications. And if I talk about 10 years later, then there was invention of some of the British signals intelligence. Okay, though, so there was no organization in the UK responsible for producing intelligence from intercepted communications prior to 1914. But the need to protect British official communications was already understood by them. And so what happened that they actually understood like what might be possible. So during the Boer War, which happened in 1914, the army had some success in reading encrypted messages. So if you see like some messages were transferred from one place to another place, and those were used by the encrypted Enigma machines, for example, and then it followed, rest followed. Okay, so we will not go much deeper into that. So then if you see 1940, the Battle of Britain. Okay, so it was actually the turning the tide with radar, which we are going to discuss in later slides. So using a new breakthrough in radio transmitters, the resonant cavity magnetron and detectors arranged at higher heights and angles to pick up the reflected radio waves bouncing off enemy aircraft, for example, RAF fighters, could be quickly directed to intercept. Okay, so what happened with this particular technology? It proved vital in winning the battle and firmly established radar as a must-have military technology. So from 1940, all the countries thought like radar is a must-have military technology, and that's why you will see now radar used by most of the countries. Then in 1952, some industrial scale jamming came into place. The Soviet Union fought an electromagnetic war on the home front throughout the Cold War, using radio jamming on an industrial scale in an unprecedented effort at mass censorship. And before this particular program came to an end, it started in 1950 to 1952 and it came to an end in 1980. but there were more than 1700 stations, if I remember correctly, were operating with an estimated combined output of almost like 45 megawatts and costing tens of millions of dollars a year to run. During that time, it was huge money. And then came 1962, where Cuban Missile Crisis, we saw like how the deceptive drones worked. And so if you can consider it like they used to be equipped with an early form of electronic deception. Drones narrowly missed some featuring in one of the Cold War's hottest moments. Yeah, the plan was to unmanned Ryan model. They were fitted with some of the drones, and to overfly the island, and drones would carry signal generators that made them seem the size of like spy plane, which are very, very small in size. But later on, they used this for, though the project was cancelled, but the UAV soon saw action over Vietnam. Next one. Okay, so this is like electronic warfare when it went to the sea in Battle of Latakia 1973. You will think of it as like it was little action which marked two important milestones in maritime history, being both like first might be the naval engagement between missile boats, and the first to feature electronic warfare. And then came the US invasion of Panama in 1989, which was like still the aircraft attack. And in 1999, what happened, like radar defeating technology passed a particularly important milestone with the first combat use of stealthy aircraft, two F-117 Nighthawks, which they were able to evade enemy detection and bomb Rio Hato airfield during the US invasion of Panama. Then came the famous Gulf War in 1991, which is also known as GPS at war. So what happened, like with target tracking and smart missile guidance, the Gulf War highlighted the susceptibility of GPS to jamming, with even some relatively unsophisticated devices proving capable of masking the weak signal from the system's satellite. So GPS, like still remains vulnerable to jamming and spoofing today. You can try it at your home. And then came the very famous like Stuxnet in 2005, which weaponized the cyberspace. So if you know, like Stuxnet is a malicious computer worm that caused significant damage to the Iranian nuclear program. And it is believed to be a joint US-Israeli development even before Edward Snowden explicitly said it in 2013. It is arguably the world's first true cyber weapon. Okay. And in 2018, like then the quantum technology came into light. So you can see here, it can be a actually game changer across the whole world of electronic warfare applications, but who leads this war will be very interesting to see. Harshit, up to you.
So imagine you are a military officer in World War I. Armies have grown so large, you can no longer communicate just by the sound of your voice or the wave of your hand. You need to synchronize movements of troops and artillery far and wide. So World War I is frequently referred to as the first modern war, since a number of technological inventions made their debut during the war. Machine guns were introduced, as were tanks, radio, military aircraft. So the army started the war using telegraph over wires, but they soon discovered disadvantages as messages being sent on them could be intercepted, and troops were traced back by following the cables network. So the use of aircraft and tanks also posed new conundrums. The solution was radio. So all of a sudden, warfare had become mobile, and it was not possible to communicate with moving tanks and aircraft without radio. In those days, they had to just turn a dial, enter in a frequency, and press a button to speak, which also led to security threat of message interception. During the later years of war, new and improved communication and electronic devices came forth from research and development in ever increasing number, which changed the nature of war forever. So here in these three images, you can see the history, how we used to the radio in previous wars. So radio technology has become extremely important in today's world. The applications is like air traffic control and navigation. We use it for military purpose, in astronomical and meteorological study, for law enforcement purposes. So continuously growing amounts of uses, clearly radio is important for many reasons. So in 1940, the US Navy developed the acronym Radio Detection and Ranging, which is radar as we know it today. So radar is a radio wave based technology that is used for detecting physical objects rather than transmitting messages. It works in a similar way to echolocation used by animals like bat. A radar system uses a magnetron to generate radio waves and broadcast them through an antenna, which serves as a transmitter. These waves reflect off objects in the environment and bounce back to the antenna, which doubles as a receiver. So the antenna repeatedly switches back and forth between transmitting and receiving by means of a duplexer. Now, radar can be classified into different categories such as pulse radar and continuous wave radar. So they are used previously, but in current generation, we use active electronically scanned array, which are considered as phased array system. It consists of an array of antennas which form a beam of radio wave that can be aimed in different directions without physically moving the antenna itself. AESA systems are currently used on many different military platforms, including military aircraft and drone, to provide superior situational awareness. The top four advantages, if we talk about AESA, it is resistance to electronic jamming, which is one of the major advantages of an AESA system. Its high degree of resistance to electronic jamming techniques. Radar jamming is usually done by determining the frequency at which an enemy radar is broadcasting and then transmitting a signal at that same frequency to confuse it. Over time, engineers developed a way to counteract this form of jamming by designing radar system which could change their frequency with each pulse. The second advantage is low interception, which is AESA system also have a low probability of intercept by an enemy radar warning receiver. If we talk about the third advantages, it is increased reliability. Yet another benefit, which is that each module operates independently. So a failure in single module will not have any significant effect on overall system performance. So AESA technology can also be used to create bandwidth data links between aircraft and other equipment. Other advantage is multi-mode capability. So let's talk about the electronic warfare, which is any action involving the use of electromagnetic spectrum or directing the energy to control or attack the enemy or impede enemy use of EM spectrum. So the purpose of electronic warfare is to deny the opponent the advantages of and ensure friendly unimpeded access to the EM spectrum. So EW can be applied from air, sea, land or space by manned and unmanned systems and can target human communication or radar or any other assets which is like for military and civilian purposes. So military operations are executed in an information environment increasingly complicated by the electromagnetic spectrum. The need for military forces to have unimpeded access to and use of the electromagnetic environment creates vulnerabilities and opportunities for electronic warfare in support of military operations. So within the information operations, EW is an element of information warfare. More especially, it is an element of offense and defense counter information. So here you can see in this particular image, electronic warfare is categorized in three categories, which is electronic attack, electronic warfare support, and electronic protection. So we will be talking about these three in details. This was previously, but in current generation, we have a new name for this, which is for ES electronic support. We call it as electronic warfare support. Um, or other name is electronic support measures. For electronic attack, we have electronic countermeasure as a new name. And for electronic protect, the new name is electronic countermeasure. So it might be possible that when you are reading, you face some different names. Now, when we talk about electronic support, so it is the main function of it is to detect, intercept, identify, locate, or to localize sources of unintended or intended radiated electromagnetic energy. So intelligence, surveillance, and reconnaissance, as Himanshu talked about, these all three and comes under these particular terms. The purpose is to provide immediate recognition, prioritization, and targeting of threats to battlefield commanders. So signal intelligence, which we also acronym as SIGINT, is related process of analyzing and identifying intercepted transmission from sources such as radio communication, mobile phones, radar, or microwave communication. So SIGINT covers electronic intelligence and communication intelligence in itself. Analysis parameters measured include frequency, bandwidth, modulation, and polarization. So in this image, you can see there's a hard kill, or the aircraft is somewhat behind, but it's showing its position of a different position. So on a radar, the position will be different. To unlock this, like if any missiles is locked, then we can use a flare, infrared flare, to miss, so that the missile misses the target. Then again, we can radiate at high power, so to noise or deception jamming. We can use the flare or chaff echoes to escape the radar receiver. In electronic attack, which is also known as electronic countermeasure, it involves the offensive use of EM energy, directed energy, or anti-radiation weapons to attack personal facilities or equipment with the intent of degrading or neutralizing or destroying enemy combat capability, including our human life. So in the case of EM energy, this action is most commonly referred to as jamming and can be performed on communication system or radar systems. So in the case of anti-radiation weapons, many times these include missiles or bomb that can home in on a specific signal, radio or radar, and follow that path directly to impact, thus destroying the system broadcasting. So if we take an example, so ELINT, where we use foreign non-communication electromagnetic information, or the communication intelligence, which is like a foreign communication transmission intercepted by other than the intended recipient. So four classes of electronic attack is one is the jamming, then modifier, we use radar absorbing materials, then physical destruction. While in a non-destructive electronic attack, we have like jamming, noise, sport. We can use chaff or flares. So we will not go in much detail about the mechanical solutions. In electronic protection, which is electronic countermeasures, involves action taken to protect friendly forces, which is like personal facilities and equipment, from any effect of friendly or enemy use of the electromagnetic spectrum that degrade, neutralize, or destroy friendly combat capability. So effectively, it is the ability to defeat electronic attack. Now, flares are often used to distract IR missiles to miss their target. Other examples of electronic protection could include use of chaff, which is like protection against radar-guided missiles, and spread spectrum technologies, so which use frequency list or emission control, low observability. Still, the technology comes under the electronic protection. Here in this image, you can see so many different kinds of electronic protection techniques. This particular is taken from Republic of Singapore Air Force. So there are so many different type of categories which can be techniques can be used. Now, if we categorize all of these in a simple diagram, here you can see electronic warfare can be divided in three categories. One is support, countermeasures, and countermeasure. In electronic support measures, we have electronic intelligence, signal intelligence, communication intelligence. The main purpose of it is to detect, to find the direction, to do analysis, or find identifying the enemy. In electronic countermeasures, we have active and passive two categories. In active, it's like deception or jamming, and in passive, we use some kind of chemicals or mechanical mechanical weapons. While in electronic countermeasures, there is anti-active and anti-passive. So that can be divided in like sport, barrage, sweep. So we will not go in much detail about it. Let's talk about the jamming. So while interference generally describe unintentional form of disruption during wireless communication, jamming describes the deliberate interference with or blocking of such communication. So as the name suggests, jamming antennas are especially used to interfere with radio noise or signals. In electronic warfare, these interference are meant to disrupt control of a battle. For example, jammers radiate, and the two main categories jamming techniques are noise techniques and repeater techniques. So it can be further divided into spot jamming, sweep jamming, and barrage jamming, which are three most common types of noise jamming. whereas DRFM jamming is the most common type of repeater jamming. Sport jamming is the form of noise jamming where jamming focuses all of its power on single frequency, so rendering the technique ineffective against a frequency agile radar. The barrage jamming is the jamming of multiple frequency at once by a single jammer. The main drawback of this technique is that the jammer spread its power across multiple frequency, making it comparatively less powerful at a single frequency. So in this example, in this image, you can see a noise jamming, which is the deliberate radiation or re-radiation or reflection of electromagnetic energy with the purpose of impairing the use of electronic devices. So let's say the green here, you can see this is a true noise, and we need to target this particular frequency, the target frequency. We can use an ideal jammer which will cover just that particular frequency, but in actual we cover some kind of offset as well, just to avoid the hopping, frequency hopping, because when you will transmit, it might be possible that at that time it will reach to the receiver, there's some kind of attenuation. So due to attenuation we will see some kind of offset. So that's why we cover the hopping as well. Now, how do we communicate while there is a jamming? So wireless digital communication system generally employ radio frequency signal to transmit information. This transmitter need to convert digital messages represented in bits to RF signal, while receiver convert received RF signal back to digital messages. While on the transmitter side, upon receiving bits from upper layer, the transmitter first modulates them to discrete baseband signal. Uh, you can see this particular image. In this, in alive friendly jamming, upon detecting a transmission, the authorized device can employ proper signal processing techniques to remove the jamming signal from the received or mixed signal. So in contrast, the unauthorized device does not have the secret key and cannot remove the interference introduced by alive jamming signals. So this image further illustrate like whereas one ally jammer is presented for simplicity. Assuming the ally jammer, the authorized and unauthorized device are in the same area. As mentioned earlier, the ally jammer and unauthorized devices, including A1, A2, AJ, share a secret key K, and the ally jammer AJ uses a pseudo random number generator with K as a key. So when the unauthorized device even transmits signal EX1 to another authorized E3 will be the mixture of both XE1 and some portions of our jamming XJ. So with enough jamming power, the jamming signal from AJ can effectively distort the signal XE1 to at E3. So as a result, the wireless communication between the unauthorized devices E1 and E3 is disabled. Now, how will we communicate if we have our own devices as well? So when A1 transmits the signal XA1 to A2, the jamming signal XJ will also distort the received signals at A2. However, since A2 share the same secret key with AJ, it can regenerate the same jamming signal XJ using K. So in real time, we have one example. In EA18G, which is from L3 Harris, Growler uses a powerful electronic attack jammer to blind enemy radar and protect allied aircraft during missions into hostile territory. So unfortunately, the very high energy from the jammer also blocks onboard communication. Now they have termed it as INCANS, which collects a sample of the jammer interference and uses that sample to create an anti-interference signal, which it then mixes into the receive path for the protected radio. The result of mixing the interference and anti-interference is that they cancel each other out, leaving only the desired reception. So this is a real-time scenario. Now, uh, this is a real-time example where the army electronic warfare technology attacks and disable tank. So army trainers successfully used cyber weapons and electronic warfare technology to thwart a simulated tank assault at a training exercise, which is jointly conducted at the Army National Training Center. The exercise reinforced the need for the electronic warfare and cyber protection technology that is under development by entities such as the Army Rapid Capabilities. These tanks had to stop, dismount, and get out of their protection, so which reduced their mobility. So exercise like this one help determine the technology and equipment necessary to achieve this effect in the field. So if we don't win the cyber and electronic warfare fight, then the next maneuver may not matter because we may not get it. So here you can see the military face a new reality, one with multi-domain challenges. The way military builds its forces, integrates its planning, and synchronize its operation must change quickly. So in modern military lingo, there are 5 interference related domains. We can categorize it in like land, maritime, air, space, and cyberspace. So the cyberspace domain is wholly man-made and is ever-changing in the emerging multi-domain reality. So an attack will often come from multiple domains simultaneously. It might be like a jamming of radio and data links, persistent surveillance, and long range fires. So even if this is a funny meme, right? What will be the warrior guardian of the future look like? So it's like a cybersecurity guide sitting behind. It will say, "Hey, dude, I'm here. So bake here." So when we talk about warfare, we should not ignore cyber warfare. It is the use of digital attack to attack a nation, causing comparable harm to actual warfare or disrupt the vital computer systems. Many countries, including the United States, United Kingdom, Russia, India, Pakistan, China, Israel, Iran, North Korea. So there's endless name, which are using active cyber capabilities for offense and defensive operations. So in terms of cyber, we can categorize these particular things in 3 categories. One is computer network attack, computer network defense, and computer network exploitation. Now, we cannot talk about all of these things because of a limited time. So computer network attack is something like most people think of when they think of cyber warfare. They envision attack taking down power grid. They envision cars being stopped in their tracks. They envision planes coming down. So those are all possibilities in theory. Now CNA is the compromise of computer based assets and manipulating the system. The system can be taken down, data can be modified, resources can be misused for botnets, or again we have seen so many different kind of attacks like ransomware. So they all can be used in military purpose as well. And the good thing to know about is like NATO designated cyber as official domain of warfare. So previously we had land, air, and sea. Now cyber is also a one of the official domain. And few months back, space was also designated as official domain. But there's a debate going on. Is like we don't want space to be used for electronic attacks or military purposes. So if we briefly talk about these particular things which we have discussed, this is an era of convergence. Military actions involving the use of electromagnetic and directed energy to control the electromagnetic spectrum or to attack the enemy. While the definitions have little in common, like CO and EW are both based on 3 roughly similar pillars, which is attack, defense, and support operation. For cyberspace operations, the pillars are defined as offensive cyber operations, which is OCO, defensive cyber operations, as well as the Department of Defense network. So in this image, you can see we have signal intelligence overlap of with electronic warfare, as well as electronic warfare, as well as with computer network operations. So we can broadly classify it. Now, according the warfare and technology make the perfect partner of destruction. Military innovations from like wooden catapults to nuclear bomb have been transforming the way war is waged since prehistoric humans carved arrows from stones some 10,000 years ago. In future, we might be seeing the robot wars or the swarm is coming like the Department of Defense in 2017 demonstrated a micro drone swarm in California, which consisted of 103 drones collaborating in decision making, adaptive formation, or self healing. So we are also seeing smart weapons like in terms of Internet of Things, IoT devices. So as we examine history, it becomes almost incredible that we would not have anticipated our great social media platform, which is also being used as a kind of weapon against us. So this within NATO, electromagnetic operations involves the deliberate transmission and reception of EM energy. In the EME, for military operations such as communication, navigation, attack, battle space awareness, and targeting. We can see in this particular figure, electromagnetic operations not only enables operation in each domain, but also provide a threat which link and integrate military forces across the domains into the cyberspace and information environment. So within the electromagnetic environment, electromagnetic operations are conducted by both friendly forces and adversaries. So these electromagnetic operations often lead to contested electromagnetic environment. In addition, these operations often overlap with the EM activities executed by neutral actors, further leading to congested electromagnetic energy. So today, the dependency of military operation upon utilizing the electromagnetic spectrum is now a central facet of almost all military activities, as military forces around the world have integrated EM capabilities into a vast majority of platform systems and unit. So we can see over here, whatever we discussed about the electromagnetic spectrum, this is how the future warfare looks like. There are so many different kind of communication and era of convergence between the cyber, land, naval, air force, space based satellites. So these all are communicating within each other in so many different way. There are jamming as well as from protection point of view, as well as from support point of view. There are countermeasures as well, which will try to hide itself. So this is an image which you can go and study in details. We can share the link for it. Now let's talk about some of the case studies, which is IED and for which is like improvised explosive devices. Now, IED is a bomb fabricated in an improvised manner, incorporating destructive, lethal, or intensive chemicals, and it is designed to destroy or incorporate personal or vehicles. So it has become an increasingly popular weapon of choice for insurgents and small armed forces over the past few decades. A favorite type of IED, which we want to discuss, is based or focused on radio control. These IED are inexpensive, very easy to build or acquire, and very difficult to trace and can be triggered from long distances. So keeping the um, operators can track it. Now, anatomy, if we talk about the anatomy, this can be further categorized. There are so many different techniques which are based on remote controls. So RECD are an effective strategy when facing a superior or technological advanced military forces. Since RCIED is a relatively simple to make, easy, hidden, and very destructive, it has become a preferred weapon of insurgents. So, like devices like two-way radio, personal mobile radio, two-way radios are a common method of command initiation incorporated in IED. Then long-range cordless telephone can be used, mobile or cell phones. So there are so many different ways like wireless doorbell, keyless entry system, car alarms, radio controlled toys. They all can be used as an IED to trigger the IED. Now, what are the counter techniques and how do they trigger? So IED will differ depending on the role that the users intend them to perform. They may be designed to cause widespread loss of life and destruction of infrastructure. So there are so many different things we want to discuss in this particular slide as well. But due to limited time, let me focus on the counter IED, which is like the efforts are done primarily by military, law enforcement, diplomatic, or financial intelligence communities and involve a comprehensive approach to countering the threat network. So you might have seen like during the whenever any president or prime minister travel, there are some kind of these cars which is using which are used to jam the IED, active IED. Now when we talk about the GEM, drones or UAV, we know they are the biggest threats in upcoming defense, and we are already facing so many different vulnerabilities due to these kind of drones. So at the beginning, when unmanned aerial vehicles were more than a toy or object of joy, no one realized how it could go in next 10 years. So technology are always ahead, and its power and speed of evolution amaze everyone. So drone is very hard to be detected by naked eye, right? Counter drone technology, also known as CUAS or counter UAV technology, refers to systems that are used to detect or disable unmanned aircraft. So as concerns mount around the potentially security threat, drone may pose to both civilian and military entities. So in reflect why radar missed drones, so we all know due to their small size, slow moving, due to low cost, they are very difficult to detect, as well as it's very difficult to detect in radar because it might be confused with some kind of birds as well. So there are these kind of techniques. We can use video based approach, in which there are some video based approach or audio based approach based on the acoustics. Then in RF power we can detect the RF signature. There are some RF active solutions as well available, or the laser scanner, through which we can detect and we can do the surveillance against the drones. Now there are so different platforms which can be used. Some are the guns which we can fire on the drones, or we can use the anti-tanks. We can use some are the we can use another drone to go and attack the drones. So there are so many different technologies to detect and counter these kind of platforms. Now Himanshu will talk about the future of warfare, and we will conclude in next 5 minutes. Himanshu, over to you.
So, okay, I'll not take much time. So if you think future of warfare, you can think of it as like a cyber warfare, information warfare, electronic warfare, command and control warfare, spectrum warfare. So those are just some of the names by which researchers and military experts describe their offensive and defensive actions. And next one. So if you can see, next slide, Harshit. So if you see, there have been many technological advances like computational power, communication network, sensor technology, space-based assets. Okay, so for when we talk about space-based assets, you can think of like satellites. And the purpose of targeting satellites would be an attempt to disrupt communication of information streams vital for commerce and security. Like you can see, like China, Russia, and other national states possess the capabilities already to do a cyber attack on the higher front. You might have seen in some of the movies like Geostorm. So the threat can be both like kinetic and non-kinetic, and counter space capabilities are emerging in the many countries' militaries. And one trend is towards the development of ground-based and space-based. So soft skill, which is known as non-kinetic counter space capabilities. Satellites could also be targeted through electronic warfare like jamming and spoofing. These are the basic terminologies, and microwave weapons, laser dazzling, as Harshit explained earlier, and perhaps most worryingly, cyber attacks. Okay, so cyber attacks, we cannot rule out any of these warfare options, and everything is important for the military to secure. Next one. So what they are doing is like most of the militaries like who have a lot of budget, they are implementing the smarter AI for the electronic warfare. And you can see like 3 closely related defense advanced research projects agency like DARPA programs. They apply artificial intelligence to the electromagnetic spectrum and will likely result in electronic warfare systems with unprecedented autonomy. So the first two, if you see here, like adaptive radar countermeasure, which is also known as ARC, and behavioral learning for adaptive electronic warfare, which is known as BLADE, are considered system programs, and they both are applying the artificial intelligence to the electronic warfare systems. So if you see like in ARC, for example, they aim to enable airborne electronic warfare system to automatically generate effective countermeasures against new, unknown, and adaptive radars in real time. So they keep on learning about the radar systems. And if you see another program like BLADE program, as we explained, they are developing machine learning algorithms and techniques to rapidly detect and characterize new radio threats, dynamically synthesize new countermeasures, and similar to ARC, they provide accurate battle damage assessment based on over the air, and they also can observe the changes in the threat. So there is a very famous dogfight which happened 2 weeks earlier. So it was the world's first dogfight between a real aircraft and an artificial intelligence driven virtual fighter jet, which was carried out again 2 weeks back. So if you see here, donning an augmented reality headset in the cockpit of Barkut 560, which they used as an experimental plane, a veteran F-22 pilot had a dogfight with the projection of a Chinese J-20 fighter. So this is what they are doing nowadays. So next slide. So we will conclude this talk. So we have discussed many topics, but what important is like how we can overcome all these. And So there are many fields to explore within this particular domain. And we should know that war fighting environment will always continue to change. So we have to focus more on the spectrum for operations. We need to learn more of the technologies that is being used by the several military agencies, governments, for example. And also we need to look not only in electronic warfare, but we also have to look in other warfare domains. So if I just add on top of this, like if you remember, like Elon Musk and Stephen Hawking were among more than 1,000 signatories of an open letter. Okay, we cannot share that open letter here, but you can check it online, which demanded a ban on the autonomous weapons, which they published in 2015. So there is always a concern, like what if they start attacking themselves or they become overpowered than humans, for example. So these are always the concerns for the countries and militaries. Thank you. So we will move to the question and answer sessions. Okay, so.
All right.
So we can see there are so many different questions being asked in Zoom channel. We will connect everyone at the Discord channel. We will collect these different questions from which were asked on YouTube, also on the platform in which we are hosting, and Zoom. And we will compile and answer all of these questions. And we apologize, like we need to speed up because there are so many different things which we need to discuss about the electronic warfare before giving an overview of it. There is so much things which are happening in an electromagnetic spectrum perspective. So you can reach us at these particular emails or our Twitter links, and we can discuss so many different stuff about it. And surely we will see you at the Discord channel. Thank you. Thank you, NanoSec, for hosting us.
Thank you, everyone.
Okay, so thank you, Harshit and Himanshu, for your talk. Now, let us introduce the speakers for our closing keynote. Saumil Shah is the founder and CEO of NetSquare. He's a well-known speaker and instructor who presented at conferences like Black Hat, RSA, PACSEC, HITB, and others. Web Hacking, Attacks and Defense, and the Antivirus books are among his books. He graduated with an MS in Computer Science from Purdue University, USA, and a BE in Computer Engineering from Gujarat University.
SK Chong is the principal consultant of ASK Pentest Syndrome Berhad. He left behind the Black Hat underground hacking life of finding 0 days, bypassing mitigation, and exploit writing for fun. As a white hat security consultant, he still does all of those, but no longer for free.
Fyodor Yarochkin is a senior researcher, forward-looking threat research senior at Trend Micro, with a PhD from EE, National Taiwan University. Besides being a programmer, he's an early Snot developer and open source evangelist. He's been a threat investigator for several years and over 8 years as an information security analyst.
Moderating the panel is our very own Razwan Mokhtar, aka Sen. Sen, aka Razwan Mokhtar, has 20 years of experience in cybersecurity. He started his career in IT as a programmer and actually got involved into cybersecurity. Right now, he is the director of RPMY. But among us, the NanoSec team members, besides being the co-founder, he's the one that makes our life miserable. Just kidding. If he actually does that, I wouldn't be saying that live. I would just whisper it. Thank you. So the floor is yours.
Thank you, Amir. Thank you for the introduction for everyone. Hello, good evening, everyone, and Assalamualaikum. My name is Sen. How are you guys? I hope everyone enjoying your day. To Saumil, SK, and Fyodor, thank you to be here supporting NanoSec. This is very special. Yeah.
Hey, guys.
Fyodor. Yeah, can you hear me clearly?
Very clearly, very clearly.
I think the last time I met you guys was a year ago in NanoSec.
Yes, indeed.
Okay, today is very special for us, with the crew as well. All right. So I would like to start this talk with my quick introductions about digital security right now, and then we follow up by you guys. Digital security has been crucial for as long as people have used the internet. Now the pandemic has affected how people do so, right? It has brought new focus to the issue. COVID-19 brings new security challenges and highlights where our old strategies may fall short and apart. From changing the working space, data being transmitted from the zero trust to your office and to your cloud, policy and SOP also been improvised. Not only that, let me go a little bit further. Cyber threat no longer a business threat too. It's been targeted individual as well. The public has been losing money and live in fears. Anyway, to start our talk today, for the closing notes, the topic about changes in cybersecurity industry. We have a very expert in the field, Saumil, SK, and Fyodor. I'm really excited to listen to you guys. So let me start with my questions. My question will go to Saumil and we'll go around the table, yeah? As an expert, can you guys hear me?
Yeah, very clearly.
As an expert, could you share what is the new changes in the cybersecurity industry right now? It's a broad question, but yeah, let's start with that.
Okay. First of all, I'm not an expert. I will try and answer the best I can what I've seen.
You're the expert of victim, right? You've been scammed so much.
Yeah. Actually, yes, I have had like 4 credit card frauds happen to me and several other scams.
Prince Nigeria contacted you personally. The Prince of Nigeria, right?
Usually the Queen of Nigeria.
Cards, for credit cards, we are sorry, we were in.
I could not hear you, Fyodor.
For credit cards, we are sorry, we will reimburse you.
Yeah. So changes are, the changes are now, how do I say it? Let me rephrase it. The more things change, the more they remain the same. We've seen a lot of changes in technology, right? But here we are again at another conference year after year discussing the same challenges. And the very fact is that the people still do not trust the safety of computer systems that are in place today. No matter what technology we've put on, the gap of trust still remains. The doubt is still there. Is my money safe in my bank? Is my identity safe? What if this gets stolen? Can I trust the person who is calling? These challenges have always remained. And with the pandemic and everything, I think the biggest change that has happened is this trust factor, the fear or the loss of trust has been amplified. This is the one change I think as a cybersecurity industry should be addressed in whatever capacity we can, as evangelists, as vendors, practitioners, advisors, whoever. Well, that's the change I've seen, and I'd like SK and Fio's opinions too. It's on this.
Maybe thank you, Saumil. Let's go for Fyodor. He's like been running outside with the lovely weather out there. Fyodor, so maybe you can answer my question. What is the new changes in cybersecurity industry right now?
What are the changes? So I think one of the core changes or challenges. So it's very difficult to differentiate what's accurate and technical and on the top, while what is just a plain scam. Like I think difficult. I think behind this is because security industry becomes so hot topic. Everyone wants to be a security expert right now. So I think it will take some time before this situation stabilizes. But right now it's very chaotic, and also black and white game. There are so many opportunities in both going black and going white. So I think for some type of people, it might be challenging to decide whether they want to go like white hat or black hat, because black hat is so much more compensation.
I thought we usually both.
Yep. So I think that's probably the main challenging thing. Like there's so much money on the black hat market that and so little chance of being caught. So it might get very attractive for, especially for the newer generation, to move on.
Yep. Thank you, Fyodor. I would like to support your statement whereby everybody want to be an expert. Everybody want to be an expert, and then
मैं काम करता हूँ, एक बार आपको क्वेश्चंस आंसर वहाँ पे पेस्ट कर देता हूँ, so that आप अपना एक बार आप चेक करिए.
hold on.
यहाँ पे इन्हें रिस्पॉन्ड कर.
Oh, that's not me.
Hold on, yeah. So yeah, to come back to Fyodor comment. So I believe a lot of people claim they are expert, even though they have only 3 years or 5 years experience. And while a real cybersecurity like threat hunting, it required 10 to 20 years experience, then you'll be able to understand it, right? So SK, what do you think about it? What is new changes in cybersecurity industry? You are directors now. Maybe you must notice the changes.
The funny thing is I think most of the things are largely similar. If you step one step back, look at the things. There are things that actually change, but I actually see a lot of similarities when we first started the security back then. 20 years ago, all those memory corruptions bugs, like, really, it wasn't easy because there was no framework, there was no shellcode, no encoder. It wasn't easy. It was challenging to write something. And 20 years afterward, it is actually still quite difficult, even though there is framework, there is encoder, shellcode, all kind of things available. But if you took a look at it, they are mostly similar. Back then there was lack of tools in Intel. Now there are lack of tools in ARM. If you want to exploit ARM, those frameworks are not available. So my thinking, if you want to be really good at something, you really have to spend some time to look into the issue itself. Go deep. If you want to do something a little bit better than other people, you need to really go deeper layer in order to find out things that most people are not able to find. What we can see, unfortunately, these days, like the one that is making money is, of course, web assessment, mobile assessment. They're good money, easy, but memory corruption bugs are, it's too long. The return of investment. So I'm talking about return of investment now. Usually, not quite worth it. Memory corruption bugs are just like too complicated and take too long to develop. But changes are like, there are things that are the same. Hackers' mindset, I would think, is the same. If you want to be really good, you need to go deep. But in terms of changes, we see less and less admin default login. We do pen tests a lot. We see less of those, but I still can see them from time to time. If you do enough pen tests, they're still admin with login, default login. But the thing is, over time, these days, most of our pen tests, easiest is just to go through social engineering, phishing. In one of the pen tests we did of 1,000 users, 700 users click the link, and 50 users, that's about 5%. 50 users just give away their username. I can, if you want to write rope-oriented, return-oriented programming, bypassing SDH and everything, that's gonna just take too long. Why don't you just send one scam email, to 1,000 users? 50 of them will just give away the password just like that, right? Yeah. So things change, but there are things change, but overall, there are largely a lot of similarities as well to back 20 years ago.
Thank you, SK. Thank you, SK. Thank you for the answers. Okay, so I believe, like you guys said, a few changes is actually on the money side, more business for you guys, right? So my second question is, right, businesses and organizations spending billions of money every year to protect them from one persistent threat, APT, and cyber espionage. I think from previous Fyodor talk, he mentioned about APT as well, right? Okay, now my concern, and I believe a lot of people would like to know this, how far this way of cyber defense accurately be able to protect customers? They spend billions of money, thousands of money, regardless SME, small companies have to buy antivirus, they have to buy firewall, and if you have the organization have big money, they can build their own SOC, hire the threat hunters. But what is the success rate? Are we actually, as a security expert, do you think this solution that we have now be able to protect the businesses and organizations? I let Saumil to start first, and then we go around the table. Okay.
we go Fyodor first on this one.
Okay, Fyodor. Before that, Fyodor, can you tell me what is the temperature at your side? It look like a lovely weather out there. The temperature, the weather?
Here, yeah, 30 degrees, I think, today, yeah.
Nice.
30 degrees Celsius, so it's quite hot. You
yeah.
can see it's all like blooming and shining.
Yep, nice. Okay, so to come back to your comments, what is the success rate based on the money being spending by the businesses and organizations on the cybersecurity?
So shall I go first, right?
Yeah.
First of all, I work for a security vendor right now, right? Security vendor is paying me money. So what I might say might not be in the best interest of any security vendor, right? But I think the key solution to security problems is human resource. Those are just tools. If you don't have people who know how to use the tools, understand what the tools actually telling you, and know how to use the tools properly, you're not going to get anywhere. And that's I think the whole story was the security. Actually, it's a human problem, both offensive and defensive. What SK said, that most successful attacks are right now the like social engineering, and I think no technology can change it because it's a human problem. And the same thing was the solution. Like, if you don't have people who understand what the threats are, how to deal with them, or even simple things when they're looking at TCP dump, understanding what they see, it's not going to like solve your problem. So the modern tools, they leverage expertise to a better scale. So before, like, I was a single person, I would only be able to monitor 10 machines. Now maybe I can monitor 1,000 machines at the same time, right? So an expert gets more effective with the tools. But at the end of the day, you need to start with having an expert into it. So that's, I think, my approach to this. So when the companies invest money into tools, they also should think that they need to have a proper human resource to pair with those tools. Otherwise, those tools would not be very useful. Hopefully, I answered your question.
SK, or let's SK go first on this, second on this.
Nothing else to top Fyodor, of course, you know, everything, he just said everything I wanted to say. Yep, pass over to Saumil.
Damn it.
But honestly, same thing over here. Tools was developed so that like to get expert easier. But the thing is, if you do not have the knowledge to use them, there is obviously no use. And in terms of social engineering, the attacker these days are actually targeting the human. You know, no amount of technology is able to save you. If you know, you can come up with something like a mitigation, something like a step to protect your user, but because they are targeting the user, attackers can always find way to, you know, make user bypass those as well. So training the user will be an important aspect in the future. Saumil,
actually, SK, yes. In fact, there was a tweet by Grug and there was a tweet by SP, Sebastian Porst. This was many years ago, I think 2015, where it's the same thing, right? The Grug was mentioning that today an APT, an advanced APT versus a social engineering attack, the success rate is very similar. Like you can get to persons by using simple social engineering scams. or you hit them with like a really advanced attack. So SP's response was actually something that stuck in my mind, that yeah, we've made a lot of efforts in software hardening, but we've made zero efforts in user hardening. In fact, the energy spent to bring the user maturity up has not happened at all. We've only invested in technology. We've not invested in users, for lack of a better word, trust generation from the users.
Thank you, Saumil. There's a very nice input. So the two times you mentioned about the biggest problem, the missing link, is the human itself. So I guess whoever listening to this talk, you must understand as well, it's quite a gap there. And then yeah, we should be able to identify the problem. Okay, thank you. For the next questions, my third question will be a bit about the technology itself, right? My next question about machine learning and artificial intelligence. Okay, machine learning and artificial intelligence was hot 5 years ago, if not mistaken, 5 to 7 years ago. Everybody talk about, before that, people talk about big data and then machine learning and artificial intelligence, and then it been deployed into cybersecurity. So I see a lot of threat intelligence, machine learning to be able to collect data, to classify the threat, right? Then my question will be, how far you see the progressions of this technology in order to protect human being? Human being is including, for me, is including business organizations. And how do we use it right now? So we have a big data, we have a machine learning ready. What are the extended of the technology? So do you see any changes for this technology to protect us, or it's just a meaningless technology just for the marketing term? Whoever want to start it first.
I'll go first.
Yeah.
See, there have been 3 decades since artificial intelligence has been talked about, right? It's been, every year they talk about it like, so this is going to be great, this is going to be great. Then it fizzles out. But something's happened. Like, we have machines that can play chess very well. We have machines that can play Gomoku very well. We have machines that can recognize faces very well. Handwriting recognition is already a done deal. Speech recognition and synthesis is now being a done deal. Translation is a big success. Dynamic real-time translation is a big success. And now the scary parts coming out are to replace the humans. Right now, well, we don't have the human-looking robots in the real world, but in the cyber world, you do have the emergence of deep fakes. You have completely ghosts in cyberspace which can almost act in real time. Not quite in real time, but near real time. You can synthesize somebody's speech, like you can actually create Saumil's speech and make him say anything. Google already did that and got caught with it. If you want to know the future of machine learning and where the technology is headed to, and I hate to say it, but the truth is in the porn industry. They will master deepfakes the first because there's money to be made there. Whenever you want to see where things are going, follow the money. Right now, deepfakes are going to be expensive because it is going to require a lot of computational power, lot of synthesis and realism to be added. And who is going to pay money for AI right now? Not the industry in general. The money will be paid by governments who want to plant spies overseas. The money will be paid by, where can you monetize it? Like the porn industry, the movie industry, they'll create like, I think there's a movie being created with this guy, right? James Dean. He's been resurrected digitally from the dead for this new upcoming movie.
Wow.
This is where the money is going to be. So by the time AI comes to helping humanity, all the devils will have done their deed. Then what's left? After the Matrix, it will be our turn.
Nice. Thank you so much, Saumil. Fyodor, you want to go first?
Yep. So here's my take on the artificial intelligence thing. So I'm coming from the academic background, and I looked into a lot of papers that trying to solve security problems with artificial intelligence. And I think there is a big gap between artificial intelligence and security. So people who are experts in security domain, they don't really know how to use artificial intelligence and machine learning tools properly to solve their problems. Likewise, people who are good with machine learning, they don't understand what they're trying to find. So a lot of papers, if you look in academic domain, when they're trying to like have a paper that talks about security and machine learning, they either not solving any problem at all, but their visualization is looking nice, or they kind of solving a security problem, but they're not using any proper like machine learning algorithms or models. They just, it's like very simple like logical scripts and stuff. So, and I think this gap of expertise is probably one of the core problems why at this moment we don't really have AI or machine learning to work properly on solving security solutions, because it's either A or B. You can be security expert in machine learning or a computer security domain, but not both. On the other hand, the development of the tools, like both of AI tools that can impersonate humans, actually making things so much easier to conduct attacks, like social engineering attacks. Like before, for example, if I want to impersonate someone and I needed to find their personal information, I probably would have to make several phone calls, do dumpster diving and so on, right? Right now, there are services where I can simply search for personal information of particular people, and that gets more and more accessible. Like things that we discussed in our presentation, like Cloud of Logs. Now I can subscribe to like logs from stealers, so I can search for both like key logs, credentials, and other information that I can use quickly to mount my attacks. So I think AI, at the end of the day, it seems that it is effectively empowering the offensive side, but for the being effective on defensive side, there is still a long way. That's how I see the existing problem.
Yeah, interesting. So I guess based on your statements, the hackers still using the old method and scripting to hack, and they be able to breach the network. Very interesting. So I will say the AI and machine learning not yet mature to help the industry. Can I say like that or no?
Yes. So the technology is not there yet. Like I think to some extent, like many companies trying to employ AI mechanisms, but I've seen situations where it doesn't work way more often when it actually works. So I'm still very skeptical about successful applications of AI in doing defensive security.
Yeah, thank you. So let's go for SK. What is your comment on my questions? How AI and machine learning be able to, and what is the progress since last 5 years? And like Saumil said, it was introduced 30 years ago. So until now,
artificial intelligence, the thing is, whenever I see like all those SIEM with AI or machine learning capabilities, actually I look into those. So it actually not working. Basically, they might have something to do with one part of the machine learning part where they can analyze, some IP address, but I would try to compare them with a simple if-then, a lot of if-then rather than just a machine learning as of now. So whenever I see all those products that claim they have AI and machine learning in those products, until today, unfortunately, I don't see anything really intelligence over there, other than a bunch of more if and thens kind of things. So in my opinion, I don't think whatever claiming they have artificial intelligence or machine learning capability in the product, especially a lot of SIEM products that we have been evaluating. We want to see how far this goes. It's actually helped in SIEM a lot. Imagine the number of data we have to, as they have to analyze. If there is a model which machine learning can help, it will help a lot, definitely. But unfortunately, we have evaluated a lot of them, but none are actually very good at the time being.
Okay, thank you. Very nice answer. So I have the same opinion with you guys as well. It just looking around, is there any possibility the solution be able to help us? Okay, my next question, right? This is about something that one of the biggest fear in industry, which is ransomware, right? So one of the biggest fear in the industry will be ransomware, right? Fyodor, your talk just now, you touch a lot about ransomware, about the criminal operations. It's very interesting. I also involved in hunting this criminal before during the COVID, during the restriction movement. Is very tricky and very interesting, right? So now cybercriminal making millions and millions of money. It's either in Russia, in Ukraine, and what I understand from there's a scammer try to scam the victims, right? In order for you to reach the solution, the decryptor, you can get scammed in the middle. So this is for me is very interesting, right? So the opportunists, the bad people, we always try to make money and without thinking about suffering that we are having. Okay, what is your opinion about ransomware right now, and what is the future of ransomware? So the businesses, we understand that they need to look into this problem. And what is your position right now in Tramicro and your company in order to help the business focus in ransomware? Please, Fyodor.
Well, to start with, ransomware, like most of the attacks that involve ransomware are not the attacks. Like ransomware is not the key point. The key point is the data. Data that belongs to corporations or individuals. That's the value that like IT technology brought to us. So ransomware attacks are simply one way of making people pay for the data, but that's not the only way. And you can also see that with the modern ransomware threats, it's not only about encrypting your data and asking for money. It's also about taking your data and threatening that this data will be public if you're not paying. And in many cases, this leverage is actually way more effective than simply encrypting the data. And you can see many of the cybercrime gangs, they actually started changing their position and running public portals where they publish dumps of the data of the customers who did not pay. And from what I see, that's a new growing trend of extracting money for the data. So at the end of the day, it's all about the data and the value that the data brings to owners of the data, and the value that the owners of the data would lose if the data gets either stolen, taken down, destroyed, or disclosed, or even shared with a competitor, right? So I think ransomware is the current stage of the cybercrime scene where suddenly it become very popular because it's so easy to be part of the ransomware gang. There are like there are partnership programs, there are ready-to-use frameworks. It become very segregated. There are like different groups of people carrying on different types of activity that builds into the ransomware attack kill chain. So, but it's not the final point. So this thing is still being evolved, and from what we see, the tendency is just running extortion for the data. So that's the thing. As a solution to ransomware problem, I think you should be looking deeper and see why were those people able to actually take and encrypt your data. And most of the time, you will notice that they were on your network for maybe a month, maybe 2 months. Maybe your network was compromised by someone else and access to your network was sold to the ransomware gang. And you only noticed that you are a victim of an attack when your data was encrypted and your systems are not functional. So the problem is that you're not looking into your security unless availability becomes a problem, unless your system stops working. So, and that's probably where things should be improving. So like proactive detection and incident response before your organization has been taken for ransom.
Thank you. Very nice. Should I go for SK?
I might have slightly different point of view. Most of the ransomware these days, agree to a point. Like it is very easy to get into the ransomware gangs these days. There's even group that can help you launder the money. How to get the Bitcoin off, kind of things. They have network to do that. It's so easy to get into the ransomware gang these days. But what I agree totally with Fyodor in this is it's all about the data. Every company have a lot of problem with ransomware these days, but there are actually pretty simple solutions. The way I see it, in real world application might be a bit different. If they just, instead of storing the file locally using a centralized web file system like Git, for example, they actually can solve a lot of default ransomware. Then ransomware might be able to evolve in a point that they will attack the server in the future. But these days, if companies just practice safe backup, simple stuff, simple security stuff, you do regular backup and you do regular your data you store in a centralized servers, for example, you can mitigate most of these ransomware problem altogether these days.
Interesting. Thank you, SK. Saumil?
Actually, listening to Fyodor reminded me so much of the talk he did, I think 10 years ago. It was called From Russia with Love. I was sitting in the audience for that talk. There's him and the Grug talking about partnerka and Skype credits as currency, and how, a short ICQ number means that you're up there, and ICQ was a currency of trust, and how you get into these type of networks. Like you can get... it's exactly the same thing, right? Once upon a time, access to networks or botnets was sold for DDoS, and then you make money out of DDoS, like $80 per 24 hours of, 99.999% of downtime guarantees. It's the same, like that. What has now changed is the way of monetization. Like today, DDoS doesn't make money because now bandwidth has gone up like by the shitloads, and there's Cloudflare and all that. So now the money is to be made by holding your data as hostage, and worse now. See, SK, the thing is, I also thought very much the same way. Like, what if I just created a very intelligent snapshot and restore solution, right? If my data gets corrupted, screw it. If I am able to restore it in real time, then I win. But just hearing what Fyodor said kind of put a different dimension. Like, it's not just about recovering your data. It is about preventing it from loss of public view, or rather it should not end up in the public. And that's another area. Like, these guys are now trying to monetize the guys who don't pay. Like my advice to customers was always like, yeah, you know what, screw it. Don't pay, restore from backups, because if you pay, it's going to happen again. Now it's like, okay, if you don't pay, we're going to make it public. And that is that's a nice threat. I mean, it's going to be a while until this type of dust settles down, until, money that has to be made out of ransomware has been already made out of ransomware, and now you go for another target. I also used to think like, okay, what if, we just change the DNA of the desktop? Like largely things succeed because it's a Windows environment, but I'm pretty sure access to a network can be obtained in one way, and then ransomizing it is another way. Those two are to be viewed as separate activities.
Interesting.
And they are.
And they are. And then they are. Totally they are. Yeah.
Okay, you mentioned about emphasize about public, right? What public think about and the reputation of the companies, right? So when you got ransom, your reputation from the public will go down. Do you mean because of public judging you, or why public see it as a bad reputation for you? So
I think they were meant the extortions of the data. Extortion, publish the sensitive data online if you're not paying. Yeah, ransomware gang do that these days.
So I will say because of these people, the public will say, you are not ready to do business. You shouldn't receive my data. I shouldn't subscribe into your apps. Something like that.
I'll give you an example. So
Yes.
there was an incident in Finland recently when a hospital was compromised and taken for ransom, and they were threatening of releasing the data, the personal records of the hospital patients if the hospital doesn't pay. So the hospital didn't pay. What they did, they reached, because they already had personal information of the patients, including their email address. So they reached out to the patients themselves and said, well, we compromised your hospital, so your hospital is not paying. But if you don't want your data to be in a public dump once we publish the data, you can simply pay us X amount of money and your data will not be included in the public dump. So at the end of the day, they're trying to find who values the data to the point that they're ready to pay for it. So it's not only reputation, but it's also that is data actually available to you, or would it be damaging to you if the data is published? So once they find this leverage, they will use it to get the money. That's, I think, the main point. It could be reputation, but it does not have to be reputation.
Yep. Nice. Okay. Saumil, anything to add on that?
I think there will also be some compliance level damages. Like if this depends on what regulation is being followed. Like if this data is dumped, then the organization has to pay like huge amount of fines in compliance violations. That can also be a proponent to extorting more money.
Mm-hmm. Okay. SK, anything to add on that? Reputations. How you own the company, right? How do you ensure that your customers you be able to protect the customers in terms of this particular topic? Do you look into?
No, everyone will come to, hey, make sure we are secure after we do patterns. No, we don't do any guarantee. Nobody should guarantee you security even after you follow everything we say. Security is a process. But like I say, big organization will be a bit tough, but smaller organizations that hit by ransomware, and then once we come in, we advise them to. It will not solve the problem 100%. They move into centralized web file sharing, and these that will help a lot in terms of like coping some of the default ransomware attack. These days, it would. Default ransomware will be just like encrypting and stealing data from your desktop. Mm-hmm. If you are storing it on a centralized web servers, they still need to be able to compromise your web server in order to get the rest of the sensitive information. So big banks and all, they will have problems migrating the whole file sharing architectures into something like this. But smaller company that we work with, they are very quickly into moving into something like that that will be able to temporarily solve most of the ransomware issue.
Okay. Great. Thank you, SK. Okay, we almost 40 minutes in the talk. So let me go to the last questions, and then we can go to Q&A after this. Let's spend like 5 minutes to everyone. Your last word to the world of cybersecurity. Your last word about cybersecurity. Maybe you can talk about anything. Maybe you want to talk about the engineers out there that been struggling, try to suit themselves with the pandemic, and also the companies that required a lot of things that added a lot of layer of cybersecurity. How you want them to stay strong? What do you advise to them, to the world? Yeah, because you guys be in industry for too long, right? What made you guys motivated and goes to this level? Yeah, anyone can start before we go to Q&A.
Well, maybe I'll start. No, I've been staying in the industry for far too long. That's totally agree. So my way of getting around it is to spend time into doing something else. So yeah, the thing is, I've been like full whole focus into security all my life. The thing is like. Sometimes you just need to take a break. I'm learning from the best, Saumil. He take his time to do photography. Yeah, so I'm spending some of my time somewhere else. These are at my age these days, so I don't do just securities. I do something else just to get along as well.
Okay.
So to others people that is getting into the security field, yeah, you have to go through like, 20, 30 years of doing like what we're doing. Then maybe you can also focus on something else in life too. Yeah.
Yep, diversity. Nice. Fyodor,
There could be other levels. Yeah, so I would have advice to people first who want to remain useful in cybersecurity field. So my take on this, try to become cross-domain expert. So not only like writing exploits, but also doing something else. Like if you're good at writing and understanding exploits, but you're also good at data mining, then your experience becomes much more valuable than simply writing exploits. And I'm not talking about the black hat applications, right? Black hat applications definitely like you can when you look at the market and see what people sell and buy on the black hat market, you can see that skills is what sells. But also on the defensive side, if you can be cross domain on multiple fields like cloud and security, data mining and security, machine learning and security, then you can your expertise becomes very valuable in building different technologies. And for people out there or like new guys, because I'm usually approached by new guys asking, hey, how do I get into computer security, or how do I become an expert in computer security? I think cross-domain expertise is probably what is the most important. That's my last word. If you want to be useful, try to become cross-domain as wide as.
Okay, so the keyword is be useful. It's a big word. Okay, I'll pass to Saumil.
Okay, that's both points are extremely valid. I cannot stress the importance of diversity, cross-domain expertise anymore. The only thing I would say to anybody out there in the cybersecurity space, be it organizations or be it individuals, be it people who are starting up, be it people who are fading away, this is a time of change. The one thing I've seen with COVID-19 is more changes have happened in cybersecurity enablement in the last 5 months than they have happened in the past 15 years. Quick examples. We also do we do pen testing, and most of the time customer insists, hey, you have to do pen testing on site. It's Asia, it's India. People have this huge fetish about keeping people on site. Like if they see them, then they feel like paying for them. If they don't see them, they don't feel like paying for them, Yeah. So we used to always say, like, customers say, oh, you have to have like these 10 people on site, 5 people on site. And we used to say, like, what's the point? It's going to increase your commute. It's going to increase table space. You have to pay for all their equipment. We can, do it from the office remotely. No. This VPN thing, we don't have a policy for that. Come COVID-19, VPNs were enabled in less than 48 hours. Everyone, like things were, all bureaucracy was thrown out thanks to COVID-19. We used to have to fly to do meetings face to face. Just for a half an hour meeting, they'll make us fly. Now, we get on a Zoom call. Great. How much money, how much carbon it's saving. And the thing is, now we've seen that we could deliver as effective services as we could, physically or remotely does not matter. We are able to take care of it. So view this as a season of change. View this as a season of optimizing your resources, saving your costs, saving your energy, and think creatively, because bureaucracy is bullshit. You can use COVID as an excuse to burn bureaucracy as much as possible. Before that damn vaccine comes through, burn as much bureaucracy as you can in the name of COVID. Go for it.
Thank you, Saumil. There's such a very nice input out there. Yeah, thank you very much. Okay, apparently we do not have enough time. We already spent 45 minutes. Let me go through the questions right now and pass it to you guys. So the first questions goes, I open it to you guys. One of the questions would be, is being gray hat still a viable career options? So yeah.
I'm gray-haired already.
Fyodor, you do not have hair right now.
Don't let anyone
gray hair
tell.
is very fuzzy definition, but I would say that a lot of people who spend enough time in computer security, you can define them as gray hat, because if you scrutinize what they've done on a period of 30 years, there could be something that would be against like the common law, but they did it for the purpose of improving like what they think is ethical state of computer security, right? So a simple dilemma: you identify a hacker machine and you know that hackers stole a lot of data from victims, and you know how to break into the machine that belongs to a hacker. Would you break into the machine? Would you report it to police? Or would you simply ignore it, right? So if you decide that breaking into the machine and taking the data out, actually, that would most likely be the most beneficial to the victims, because you're taking the data out, you notify the victims on time. Victims will take precautions, like less money would be lost. So it would be probably like the most ethically reasonable action. But if you look at this from the point of like legality, that would be plainly illegal, because you don't have authority to do this, right? So to go back to the original question, is being gray hat still an option? I would say if you don't talk about this, go ahead. But I think most of people I've seen through my career who like they've been very good, notable security experts, but they suddenly get in trouble with law is because they either talking or sharing or flashing what they get through activities that are not extremely legal, right? So if you want to be a gray hat, yeah, why not? But just don't talk about this. That's the whole point. And I'm not supporting any illegal activity with the statement. It's just a matter of opinion.
Okay, thank you for your opinion. I really appreciate it. SK, what do you think about it? Before I jump to another question, yeah.
Well, don't let anyone tell you what you can or cannot be. Well, the thing is, you know, it doesn't mean you are black hat if you get caught. You know? Just because you get caught doesn't mean you're good or you're black hat. You know, they are good hackers that never get caught. You know, yeah. There's and the way I see it, most security expert I know, a little bit of both. You know, they're trying things out. You know. Now, who haven't hacked some of your friends' desktop for fun, prank, and things like that as well, right? So it's always going to be a little bit of black and white hat, you know.
Okay.
Hey, Kevin Mitnick is more famous and richer after he got out of jail. Just remember that.
Yeah, true. It's not an option for you. You're already a gray hair. Anyway.
Done. I'm one of those, yeah.
No options.
Out there, guys. I'm on my way out.
Okay. So, question to you, Mr. Saumil. From one of our audience, right? You mentioned about deepfake earlier. Okay. So how can we detect or differentiate deepfake videos? Can it be done with the naked eyes, ears of any of the Shah software?
Excellent question. This leads me to my theorem on problem spaces, which I invented myself about a month ago.
Wow.
The theorem states that a problem that is created from one space cannot be solved by a solution from the same space itself. Which means that if a problem is created using technology, you can't solve it using technology. If a problem is created using policy, you can't solve it by more policy. What I'm trying to say here is I don't have a damn good answer to this. But this much I know, that no amount of technology will help you detect deep fakes, because technology itself is used to generate the deep fakes. And if today there's a detection technology, there will be a deep fake technology which will overtake the detection. And then you've seen this with, antivirus. It's like, here we go, the Tom and Jerry game happens again. and solve it using something else.
Yeah, I have slightly different opinion about this. Obviously, AI will be very useful in this case. If you train enough AI to recognize deepfakes, they will be very good at recognizing deepfakes. So a problem created by AI should be solved by AI.
Yeah, why not? So we have less work for us, I guess. Yeah, Fyodor, anything to say about that, Fyodor? You seem like want to say something.
Yeah, we were actually playing around with this idea, and one of the solutions we came up with, if you force all of the video recording devices to produce blockchain, if you produce cryptographic signatures that are stored in the blockchain for every video, then for every player, if you could have a mechanism that verifies the signature to ensure that the video is authentic and coming directly from a video recording device, that would probably be some sort of solution, like for fake videos that might make significant difference in either political landscape or in court. So in order for a video to be usable in court, this whole chain of authenticity has to be proven. But at the end of the day, like a lot of people who watch videos on Twitter or YouTube, they would not even, or like even watching the video, like we're not even talking deepfake, like read a title of fake news, and they get carried away with it because the idea that they get from the title matches what they want to read from the news. And I think that's probably a biggest problem here than deepfake. Deepfake is just a tool to make people believe what they want to believe. But there are other even simpler mechanisms in making them believe in what they want to believe. Like, for example, why some personas during election become more successful than others, because they just push populist agenda when they speak, right? So it's part of the human nature. So even though like you could have technical measures to solve these fakes for things like usability in court or proving things, it's not going to change how society responds to.
Okay, thank you, Fyodor. Very good input. We have 2 more minutes before we end up our sessions. This question goes to Saumil. Based on you made a paper, right, about deepfake, right?
No, I did not.
Oh, you did not?
No.
Okay, so I thought you still mentioned it. So Saumil, just for the questions, right? Do you think this kind of deepfake should be applied in terms of policy? I mean, there's a law mentioned who own the deepfake. It should get caught, and then certain that it should be like nuclear weapon. We restrict countries to develop it. Can it be done in terms of deepfake? What do you think about it in the policy parts? Yeah.
I don't know. Have we really solved the nuclear problem when dear leader is still blasting rockets off right now? See, the nuclear problem is a very interesting one. The only way you can regulate a nuclear problem is by mutually assured destruction. Yeah. You try to do something funny, we'll bomb the shit out of you. That's the traditional response in several layers of diplomatic language. But right now, of course, there is a big ethical debate going on about like the ethical use of AI. The problem is nobody's listening to it, and the companies with the trillions of dollars in their pockets are doing exactly what they please. No government right now is powerful enough to regulate the trillion-dollar corporations. They're not going to be able to stop them from doing this. What the people do is ultimately going to be the choice. But regulation will truly, I don't have much faith in regulation, if you ask me. There'll be discussions and there'll be like, United Nations bodies set up only to be ignored. But it is something that has to kind of come as a social movement, that this is just not going to fly. I don't know what shape or form it is, but the solution will have to come from the population at large, either through sensitizing them or any other means.
So it's hard also to apply in policy part, right? So what about blockchain? Because Vladimir Kropotov, right on my right, mentioned about blockchain probably is an option to fight deepfake. That will be my last question to anyone. Is it? Do you think it can stop, blockchain can stop deepfake? Anyone? Yeah.
Yeah, let me answer this first. I think blockchain could be used as a means of verifying or tracing a video to its source. So if you want to record a video, so take it the other way. You cannot tell which video is fake and which video is not. But if you want to make a video that is provable that it's not fake, then you could use blockchain to build provable videos. And then you could use those videos in situations where you need to prove that certain action happened and there would be no doubt that it's a fake video because there was a hardware, like black box hardware implementation that recorded and signed it. Of course, at the end of the day, details might be in implementation and there are always problems in implementations and people might find vulnerabilities how those signatures would be replicated. But I think if we wanted to go towards solving deepfake problem, we should start with building mechanisms of being able to produce provable videos that where authenticity of the video could be traced. So that's how I think blockchain could be helpful.
Okay, thank you, Fyodor. Saumil, anything to add before I end up the sessions? SK, should I end it? Okay. Okay, guys. It's exactly 1 hour the session already. So sorry for maybe next year we should do 2 hours so we have more longer topic to cover.
Next year we should meet up.
Even half day.
We should meet up.
We should meet up. I want to have a beer or something.
Damn straight, man.
It's on NanoSec then. Okay, guys. Thank you very much. I really like the conversation. You guys are very responsive and very nice. So I'll pass my my closing speaker to Amir and Hidayah. Thank you, speakers. Thank you, everyone, for watching it.
It was great to see you all. It was really good to see you, folks.
Yeah, great to see you guys. Hey,
Good to see you
Saumil.
too.
Hey, yeah.
Take care.
All right.
Bye-bye.
Ciao.
Ciao.
Thank you, Sen, Saumil, SK Chong, and Fyodor for the keynote. I mean, I hear people saying AI will take over our jobs in the IT industry. Well, honestly, I don't think so. I mean, like, our clients are going to need to state their requirements accurately. Not going to happen anytime soon, at least. Truly, though, jokes aside, we have a lot of work to keep ourselves safe online.
Oh, yes, I agree. With the advent of IoT devices, cybersecurity is more important than ever.
Absolutely, Hidayah. Sorry, what was that? We have come to the end of the event. Okay then. We, the NanoSec team, would like to thank you for being here for this wonderful virtual event. We'd also like to express our gratitude to our sponsors, namely ASK Pentest, My Security Community, and Sides 2021, and to all of the speakers.
Ame, not to forget, thank you to this year's participants. You are the reason the event even happens. After all, we are community driven.
Of course. A special thanks also to my fellow NanoSec team members that have been working every day together.
Yes, the long nights, the laughter, the good vibes are what make this event happens. After all, a team that loves together takes on the world together. Truly, Ame, to me, this team defines the saying, teamwork makes the dream work.
That's right, Hidayah. We've come to the end now. Well, I know that's the second time I said that. I know, but I wouldn't feel like a professional MC if I don't keep on saying we've come to the end now when it's actually not the end. So let me be, okay? Anyways, don't be sad, don't cry. To all of you, NanoSec will be back again next year. And if you truly can't wait for next year to see our faces, well, you can always rewatch this stream on YouTube or find us on our social medias. We'll also announce our latest activities there as well as on our website, nanosec.asia. Stay safe, everyone. Goodbye.
For real this
Bye.
time. Goodbye.
Goodbye, everyone.